learn microservices. The reason why you should learn and master microservices is these days, many organizations, they are migrating their monolithic applications into microservices. The reason is microservices architecture makes applications easier to scale, faster to develop, enable innovation, and it is also going to help organizations by accelerating the time to take their new enhancements to the market. So with all these reasons, microservice is going to be a demanding skill set for next few years. So to help you mastering microservices, this course has been built. Let me try to quickly cover what is the agenda of this course, what exactly I'm going to cover throughout this course. First, we are going to start the course by entering into the world of microservices. I'm going to give a formal introduction about what is microservices, how they are different from monolithic and SOA architectures. Once we are clear about the microservices architecture, why we should build microservices, I'm going to explain you how to build microservices with the help of Spring Boot by following the production standards. These standards includes best practices while building REST APIs, how to document your REST APIs, how to perform validations on top of your REST APIs. All these standards and best practices we are going to discuss while building microservices throughout this course. And apart from building microservices, I'm also going to teach you how to right size your microservices, how to identify boundaries, and how to containerize your microservices with the help of Docker. Because without knowing on how to containerize your Spring Boot application, you cannot really build microservices. That's why learning about Docker is very basic need for a microservice developer. So once we learn about how to containerize our microservices, I'm going to explain you how to maintain configurations inside your microservices with the help of Spring Cloud Config Server, followed by how to build your own service discovery and service registration inside microservices using Eureka Server, and how to build an edge server or an entry point into your microservice network with the help of Spring Cloud Gateway. And apart from building your microservices, you should also take care of making your microservices resilient and fault tolerant by using standards like resiliency 4J patterns. So these patterns are also discussed throughout this course in detail. Once building microservices is completed, you should also take care of how to implement observability and monitoring inside your microservices by using supporting components like Grafana, Prometheus. So all these components we are going to explore, and we are going to implement observability and monitoring inside our microservices. And we can't climb our microservices as production ready without securing our microservices. That's why we're also going to put good amount of efforts in understanding how to secure our microservices using OAuth2, OpenID, Spring Security frameworks. And sometimes you may also want to build some microservices which can process the requests asynchronously. So to handle such scenarios, I'm going to explain you how to build event-driven microservices with the help of RabbitMQ, Spring Cloud Functions, and Spring Cloud Stream. Very similarly, we're also going to explore how to build event-driven microservices with the help of Kafka as well. And at last, we're also going to learn on how to deploy all our containers into a Kubernetes cluster. So Kubernetes cluster is a container orchestration product. At the end of the day, all our microservices has to be deployed into a Kubernetes cluster. That's why we are also going to focus on learning about Kubernetes, how to deploy your microservices into a Kubernetes cluster. And once we are clear about Kubernetes, we're also going to learn about Helm, which is a Kubernetes package manager. Once we are clear about Helm, we're also going to deploy our microservices into one of the cloud environment. So by logging into a cloud environment, we're going to create a Kubernetes cluster and deploy all our microservices into cloud environment. Apart from all these components, we are going to learn many best practices, techniques that are followed by the real-time microservice developers. So with all this agenda, this course is going to help you to master microservices and clear any interviews. Apart from this course agenda, I also want to highlight that entire course is built using easily understandable format. Any complex topic, you'll be able to easily understand with the beautiful visuals that we are going to discuss throughout this course. All these visuals is going to help you to easily digest any kind of complex topic. And I'm also going to share you all this content in an PDF format for your reference, so that in future, whenever you have some questions, you can always refer this PDF for any questions and quickly refresh your microservices skills. This PDF I'm going to share is also going to help you to save some time from taking notes. So with this, it should be pretty clear for you that I have put good amount of efforts to build this information in an easily understandable format. I also want to clarify you that throughout this course, apart from theory discussions, apart from discussing about various concepts and best practices, we're also going to build good amount of microservices, and there are enough hands-on discussions that we are going to make throughout this course. And in the same process, we are going to explore many best practices, standards, products, tools that are going to make our life easy while building production-ready microservices. I hope this is clear to you. So please go ahead and enroll into this course without any questions, and we are together is going to enjoy this microservice journey. Thank you, and I'm hoping you to see in the next lecture. Bye. Let me start the journey of microservices by introducing what are these microservices inside this lecture. In a simple language, we can call these microservices as one of the architecture style that we can consider to build our web applications. So to understand more about microservices, let's try to take an bank application with the name EasyBank. And this bank application, just like any other bank application, it provides various products to its customers with the name accounts, cards, and loans. So for this EasyBank, in order to build a web application, there are multiple architecture patterns available inside the industry. The very first traditional approach that that we have to build web application is monolith. Whenever we are following the pattern of monolith, all the business functionality of a bank application, they will be deployed as a single unit. If you see here, inside a single server, it has a presentation layer related logic like HTML code, JavaScript, CSS, and post that there is going to be a backend business logic along with that data access layer. And one more important feature of monolithic is it is going to have a single supporting database where we store all the data related to accounts, cards, and loans. This is the architecture style that companies or developers, they used to follow back a decade. And of course, this approach has its own advantages and disadvantages. So first, let's try to understand what are the advantages of this monolithic architecture. The very first advantage is this architecture style supports simpler development and deployment for smaller teams and applications. If you have a small team or if your application is a very small application, definitely this pattern is going to make sense because it is going to ease your development and deployment. With a single deployment, all your web application is going to be deployed and it is going to be available for the end users. And on the similar lines, since we are deploying everything inside a single server, there are going to be a fewer cross-cutting concerns. When I say cross-cutting concerns, all your non-functional requirements like security, auditing, logging, this is going to be simple inside monolithic because all your code deployed inside a single server as an web application. And the next advantage that we have with monolithic is it is going to provide better performance due to no network latency. Why better performance? Because all the code is deployed inside a single server. If accounts business logic want to communicate with cards or loans, it is just going to be a method call inside the same server. There is no network call with the help of web services. So with this reason, monolithic applications, they are going to have a better performance. Now, these are the advantages. Let's go to the disadvantages of monolithic. With the monolithic, the primary disadvantage is it is difficult to adopt new technology. Like whenever I want to enhance my web application with the new frameworks or with the new languages or new technology, either I have to update my entire code base or I need to continue with the old technology. Sometimes the accounts team members, they may want to move to a latest framework or latest language or latest version of the framework, but there'll be a pushback coming from the cards and loans team members. So with all these reasons, it is going to be difficult to adopt new technologies. And with that reason, very limited agility inside a monolithic applications. It is not going to work like you decided to move to a framework or a new language today, and you can't do that immediately in a week or a month time. It is going to take a lot of time to upgrade your monolithic application because entire your code is tightly coupled. We never know what issues it is going to create when we try to migrate. With that reason, a rigorous testing and regression has to be done on top of your web application. And since we are going to maintain everything inside a single server, all the code related to your web application is going to maintain as a single code base, which is going to be difficult to maintain over the time as your application is growing with the new enhancements day by day. And the next disadvantage that we have here is your application is not going to be a fault tolerance, which means you're going to be having frequent issues with the scalability, availability of your monolithic application. And the last disadvantage, like you can see, since you deployed everything inside a single server, if loans development team, they want to introduce a small feature or if they want to make a small enhancement inside their code base, it will require a full deployment. Due to that reason, your entire web application is going to be having a downtime. And this is going to be a super drawback whenever you're dealing with the end users who uses your web application 24/7. This monolithic architecture is developed in various forms inside the industry like single process monolithic, modular monolithic, distributed monolithic. Regardless of what is the form of monolithic pattern is being followed, it will have all these drawbacks that we discussed, and it is going to be having only a single supporting database. I hope you are clear like what is monolithic architecture pattern. Let me try to explain monolithic by taking a different perspective. Inside our Easy Bank web application, typically there will be development team handling the accounts, loans, cards, and UI UX. Inside monolithic applications, all these developers are going to work on a single code base, increasing on day-to-day basis. Slowly, the industry migrated to a new architecture pattern, which is SOA. SOA means service-oriented architecture. Let's try to understand what is this service-oriented architecture. The main enhancement that happened inside this SOA architecture compared to monolithic is organizations, they can segregate their UI logic and backend logic. Like you can see here, I'm going to deploy the presentation layer or UI logic into a server 1. And inside the server 2, I'm going to deploy all my logic related to accounts, cards, and loans with the help of web services. With this pattern, at least I'm able to separate the tight coupling between UI and the backend logic. But like you can see here, for this UI to communicate with the backend services, we should use a middleware component, which is Enterprise Service Bus. So whenever a request comes to this ESB is going to redirect that request to the correspondent service, like whether the UI application is trying to fetch the accounts information, cards information, or loans information. Accordingly, it is going to redirect the request to one of the web service inside the server 2. So we are able to separate the UI logic and backend logic into two different servers, but this architecture also has its own advantages and disadvantages. First, let's try to understand what are the advantages. The advantages are like reusability of services, better maintainability, higher reliability, and parallel development. The reason why we have these advantages is you have separated all your logic into separate components, like all your accounts related logic is going to be stay inside the account service. Similarly for loans and card service, and coming to the UI code, it is going to be separated into a separate code base, and it is going to be deployed into a separate server as well. With all these reasons, we can achieve parallel development, better maintainability and reusability of services, and higher reliability. Now coming to the disadvantage of this architecture is the communication is going to happen with the complex protocols like SOAP. Using SOAP and XML format, the communication between the UI and backend server is going to happen. Compared to other protocols like REST, SOAP is very complex in nature and heavy in nature. That is one of the disadvantages that we have. And like you can see here, we have a middleware component, which is ESB. And to set up that ESB, we need to put a lot of investment because these are not open source. These products are like commercial products. Like Oracle has an ESB product, which is costly in nature, and it is an extra overload in between your UI and backend services. Why should we maintain a separate component just for communicating between UI and backend services? So in the initial days, projects, they use this SOA architecture, and to some extent, they got the benefits like parallel development, reusability of services, and better maintainability. But slowly, industry felt that this architecture pattern also very complex to maintain, and it involves higher investment cost. So with all these reasons, everyone started looking for a better architecture style, which will overcome the challenges of SOA and Molthic. That's where we landed onto a new architecture style, which is microservices. So before I try to go to microservices, let's try to understand how SOA is going to look like by taking the perspective of GitHub and Jenkins that we discussed. So initially, like you can see, we are going to have UI UX dev team, accounts team, loans team, and cards development team. Inside SOA, like you can see, UI team, they're going to have separate code repo and development lifecycle, deployment lifecycle. And with that reason, it's going to increase the agility in containers. With that, like you can see, we're going to enterprise service bus. So to some extent, services architecture. So let me try to explain you what is microservices. So whenever we are developing our web application, for example, the same EasyBank web application, we are going to develop many services that are modeled around a business domain. I can have separate small microservice focusing entirely on accounts logic, and similarly for cards and loans. This way, based upon separate business domain logic, I can segregate them into separate services. And all these microservices, they're going to have their own database. They're going to be deployed into their own servers or own containers. With that, like you can see, we're going to have all our UI logic inside a server one. Coming to the backend services, we can create any number of microservices that can be deployed into separate servers and containers. And all these services, they're going to have their own supporting database. So let's try to understand what are the advantages and disadvantages of this microservice pattern. Coming to the advantages, like it is easy to develop, test, and deploy because you loosely coupled all your business logic. All your accounts related logic is going to be stayed inside a small component. If you want to enhance accounts microservice with a new language or new framework, you can happily do that because it's entirely a separate component which will have its own development lifecycle, deployment lifecycle. And with that reason, it's going to increase the agility inside your organization. Since there is no tight coupling between your microservices or services, all the development teams, they can have their own enhancement lifecycle, they can have their own discussions, they can have their own deployment lifecycle. With that, we are going to achieve the parallel development. And the beauty of microservices is it is modeled around your business domain. Like for example, inside the EasyBank, we have accounts, loans, and cards. So I can have 3 microservices focusing these 3 different business domains. And since we are going to deploy all these services into Docker containers, which I'm going to explain you in the coming lectures, it is also going to provide you flexibility where you can scale horizontally and independently. For example, if your accounts microservice is going to receive higher traffic compared to loans and cards, you can scale only accounts microservice independently. So these are all the main advantages of microservices. And please don't assume that microservices is a silver bullet for all your problems inside the web application. You should not always jump into microservices because it is unnecessary for smaller applications or smaller companies. So that's why let's try to understand what are the disadvantages that we have with microservices. The very first disadvantage is it has complexity because when you have so many independent containers deployed separately in different servers and clusters, definitely connecting them and making sure they're able to communicate properly always is going to be a complex task. And it is also going to be infrastructure overhead. Inside Molthic and SOA, you only have 1 or 2 servers to monitor. But inside microservices, you're going to deploy your microservices into number of servers and containers. With that, you need to monitor all of them. That's why there's going to be infrastructure overhead. And there are also going to be security concerns because previously any communication between your code used to happen with the help of method calls and a web service call from UI to backend. But now with microservice, even your backend services, they need to communicate with web services like REST-based services. And this increases security concerns inside your web application. But don't get demotivated with all these disadvantages because at the end of the day, organizations, they want agility and they want a freedom to enhance their web applications and microservices whenever they want, and they want to go to the market as soon as possible. Since microservice is going to provide all these advantages, they are ready to face these challenges. And of course, we have various approaches to overcome these challenges inside microservices architecture. We're going to discuss all of them inside this course. If there is one crucial takeaway that you want to take from this course and the concept of microservices is microservices, they're going to prioritize the independent deployability of your services. And whenever you're deploying your own microservice, you're not going to have any dependency on other microservices. With this primary advantage, all other numerous benefits will naturally emerge inside your microservices web application. We're going to discuss what are those. Now let's try to see how the microservices is going to look like with the GitHub and Jenkins scenario. You can see there are 4 different development teams inside microservices architecture pattern. All of them, they are going to have a separate code base. At the end of the day, it is going to give super freedom to your company and to the developers. They are free to explore because they are not bounded to a single code base or to a single server. I hope you're clear with all the architecture patterns that we have like Molthic, SOA, and microservices. What are the advantages and disadvantages of each of these patterns? Let's try to continue the discussion of these microservices inside the next lecture. Thank you, and I'll catch you in the next lecture. Inside this lecture, let's try to compare the three architecture patterns that we discussed in the previous lecture. Like you can see on the left-hand side of the slide, we have monolithic architecture. The primary characters of monolithic application is we're going to deploy all our code base inside a single server, and it is going to be supported by a single database. With this, we have tightly coupled all our components of a web application and business logic into a single server. Now moving on to the SOA, we separate the UI and backend logic, but we're going to have separate code base, separate development and deployment lifecycle. I hope you're clear like what is difference between them. Now let me put one more perspective in terms of monolithic SOA and microservice. So I'm going to compare these monolithic SOA and microservice by taking different features. The very first feature is parallel development. You can see inside monolithic, there is no parallel development. The developers are going to cry. Whereas in SOA, it's not an happy scenario or a sad scenario. It is somewhere in the middle because at least you are providing some flexibility between UI and backend teams. Whereas in microservice, it is going to be the winner. You are providing complete freedom to the different teams in terms of parallel development, deployment, and enhancements. The next feature is agility. With monolithic, there is no agility. You can't enhance your web application with the new frameworks and new languages because it requires a lot of effort. And SOA, you can do to some extent. Whereas in microservice, you're going to have a lot of agility because all the teams are working independently. And in this scenario, also microservice is the winner. The next feature is scalability. Coming to scalability, inside monolithic, it is going to be very tough to scale your web application because you're going to deploy all your code inside a single Jumbo server. If you want to scale your web application, you need to bring one more Jumbo server. You need to take care of load balancing between them, which is like very manual setup, and it is going to be very challenging. And to SOA also, the scale like Docker and Kubernetes, we're going to discuss about them. So in scalability also, the winner is microservice. Coming to the usability, inside usability also, the clear winner is microservices because your developers, they're going to bring many new enhancements, and they are going to deploy their new enhancements within a matter of days. Think of a scenario where accounts team, we're going to discuss all of them in the coming lectures. So inside usability also, the winner is microservice. Now coming to the complexity and operational overhead. Of course, here the key components, UI server, backend server, and frameworks that we have inside the microservice ecosystem. And the last feature is security concerns and performance. And here also the winner is going to be monolithic. And inside microservice, the security concerns are going to be more, and there'll be some performance issues because every silver bullet for all your problems, for all your web applications, you need to be aware under which scenarios we can go for monolithic, SOA, and microservice. I think these days no one is following SOA. It's a discussion about whether monolithic or microservice. If your web application is small and your organization is very small and you don't need frequent deployments, then you can always go with monolithic. Whereas if your application is large and your organization requires frequent deployments, frequent enhancements, then you can always go with the microservices architecture. I hope you're clear. Like the reason why I've discussed so much about monolithic, SOA, and microservices is if you go to any interview, there'll be definitely questions around microservice, and they'll ask you under which scenario I should go for microservice and monolithic. So please always have this information. And I'm sure with this knowledge that you have gained in these two lectures, you can explain about what are microservice, monolithic, and SOA to anyone. So please. Inside this lecture, let me try to provide a formal definition of microservice so that if someone asks you, you should be able to answer it quickly and easily. You don't have to explain all the concepts that we discussed previously to a non-technical person. So if some business user or if some client asks you, what is the definition of microservice or what are microservice, then you can tell this definition. And this definition is defined by the James Lewis and Martin Fowler in one of the blog article that they have written. So like you can see, microservices is an approach to develop a single application as a suite of small services. Inside EasyBank web application, we can develop a web application as a suite of small services with the name accounts, loans, and cards. And each of the services they can run in their own process, and they can communicate with lightweight mechanisms like REST. And all these microservices built around business capabilities or business domains. And most importantly, they can independently deployable by fully automated deployment machinery. We can automate everything. Like as soon as a developer check into the code base of a microservice, the build will happen, and the same build will be deployed automatically into Dev and UAT environment. And if needed, we can also automate the deployment into production using CI/CD concept. So there are many advantages with microservice, which we are going to learn inside this course. But on a high level, this is going to be your simple go-to definition of microservice. I hope this is helpful. In the previous lectures, we had a very good discussion about what is microservice and how they are different from monolithic and SOA architecture. Now, you agree that microservices are good and we have many advantages with it. The very next question that you may have here is how we can build the microservices inside any project. Because at the end of the day, some great developer has to develop these microservices by using backend language like Java. In this entire course, I'm going to present multiple challenges that we are going to face while we try to build microservices. So first, I'll try to introduce what is the challenge that we are going to face. And post that, I'm going to show you what is the best solution or best standard that you can follow to overcome that challenge that you may face while building the microservice. So here inside this lecture, I am introducing the very first challenge, which is how we can build a microservices. Because inside traditional web applications, for example, inside any monolithic web application, we develop all our code with the help of Java classes, methods, and we package it as a var or ER file. Post that using the same packaged file, we can deploy into a web server like Tomcat or any other application servers. And this is going to be a super time consuming process. First, you need to develop the web application. You need to package your application. application you need to deploy into your web server. So since this is a time-consuming process, do you think this is going to work for building microservices? Of course not, because inside real-time projects, bigger organizations, they may build hundreds or even thousands of microservices. So building, packaging, and deploying all these microservices using traditional methods is going to be extremely challenging, and it is going to be a practically impossible task. So do you know how to overcome this challenge? I'm going to give 5 seconds, and please try to guess the solution for this challenge. 1, 2, 3, 4, 5. Let me show you the best solution that we can use to overcome this challenge. Like you can see here, the solution is Spring Boot framework. With the help of Spring Boot framework, we are going to overcome all these challenges. Don't worry, I'm going to give good introduction about what is Spring Boot and how it is going to solve this challenge 1 that we are going to face while building microservices. Throughout this course, I'm going to use the Spring Boot framework to build the microservices. So I'm going to do my best to explain all the concepts that we are going to use. But if you are new to the Spring framework, and if you're not aware of the basics of Spring framework, like what is a bean, what is auto wiring, then I would recommend you taking a course focusing on Spring framework. First, be very clear with the basics of Spring framework. Once you are clear with the basics, you can happily continue with this course. I also have a Udemy course focusing on the Spring framework, where I will try to teach everything about Spring framework, Spring Boot, how to build REST services, what is Spring AOP, Spring MVC, Spring security, Spring data JPA. So all these concepts I'm going to discuss in this detailed course. So if you are interested, please enroll into this same. Once you are clear with the Spring framework, then only please continue with the course of microservices. But if into the world of Spring Boot. Thank you, and I'll catch you in the next lecture. Bye. In the previous lecture, we discussed about the challenge 1 that we may face while we are trying to build microservice. And in the same lecture, I have told that Spring Boot framework is the best framework to build Java-based microservices. So here you may have a question like, what is Spring Boot framework? Why it is the best framework to build Java-based microservice? So let me try to answer the same question inside this lecture. Spring Boot is a framework that built based upon that Spring framework. With the help of Spring Boot, we can develop and deploy Java-based web applications, including microservices, very easily. It is going to improve the productivity of the developer. It is also going to make the life of developer and platform team and operations team very easy with all the features that it is going to support. And with the help of the Spring Boot framework, we can build self-contained and executable jar files instead of traditional var or EAR files, which means you as a developer just focus on your business logic, and the framework is going to take care of starting your application and packaging your application and deploying your application into an embedded Tomcat server or into an embedded web server. So whatever jars that we are going to generate with the help of the Spring Boot applications, these are self-contained, which means they're going to have all the dependencies that they require to run the microservices. So this approach eliminates the need of external web server like Tomcat or JBoss or any other application servers, and we don't have to maintain all of them manually. Apart from these major advantages, we also have other advantages with Spring Boot framework. So let's try to understand one by one. The very first advantage is whenever we are using Spring Boot framework, it is going to provide lot many built-in features and integrations with the help of concepts like auto configuration, dependency injection, and it also supports various cloud platforms. So let me break this into simple words. Whenever we are using Spring Boot framework, think like you are trying to create a web application. As soon as you're trying to create a web application with Spring Boot framework, it is going to make auto configurations to deploy your web application into a web server like Tomcat at a default port of 8080. So all these kind of auto configurations, it will try to do by itself by assuming some default values. If you as a developer, if you are not good with those default configurations, you can always override them with the help of properties inside the Spring Boot framework. Everything we are going to discuss in Spring Boot, I'm going to show you the demo of them when we are trying to build microservice with the Spring Boot in the coming lectures. The next advantage that we have is, like we discussed, whenever we are using Spring Boot framework, it provides an embedded servers like Tomcat, Jetty, or Undertow, which you can use to run your microservices directly without the need of a separate server installation and maintenance. After this, the next advantage that we have is this Spring Boot framework supports lot many production ready features such as providing metrics about your web application, health monitoring, and external configurations. So whenever we're trying to build web applications inside monolithic approach, we as a developer need to write a lot of code to monitor our web application, to produce metrics from our web application, and to configure some external configurations. Whereas with Spring Boot, everything is going to be super easy with the dependencies like Spring Boot Actuator. So we're going to explore what is Spring Boot Actuator, how it is going to expose all the metrics, health information, and configuration details about our web application in the coming lectures. The next advantage that we have is we can quickly bootstrap a microservice project and start coding with a range of started dependencies. In the coming lectures, I'm going to show you how quickly and easily we can create a microservice project with the help of Spring Boot. And before Spring Boot, whenever a developer want to add a dependency related to some database or some message queues or some other framework, he need to do a lot of configurations inside his project, and he need to add a lot of dependencies manually. But with the help of starter projects inside Spring Boot, it is going to be super easy. You as a developer just tell what dependencies you have inside your web application. Suppose if I'm trying to connect to a MySQL database, I can define that End of this course, I'm also going to show you a demo of how to deploy our microservices into a Kubernetes cluster. I hope you're clear with these advantages. Let me show you a different perspective on how Spring Boot is going to make our life easy. Like you can see here on the left-hand side, we have a traditional approach which we will use whenever we are building monolithic web application back a decade when Spring Boot is not yet released. So you can see to build and deploy monolithic web applications, first we need to have Java runtime environment like JVM. On top of that, we should also install our web servers like Tomcat, Jetty, Netty inside our server or inside our laptop. Once we have these two components ready, then we need to package our applications into var or EAR format, and we need to deploy them manually into a server. And with the help of runtime environment like JVM, our web applications will work where an end user can use them. Whereas with Spring Boot framework, you can see the middle component, which is servers, we got rid of this server component because this server component right now is embedded into the jar of your web application or of your microservice, which means whenever I'm trying to use Spring Boot to build my microservices, it is automatically going to package my application along with the embedded server. So as a developer, I don't need to worry about all the server installations and maintaining of all these servers configurations. And this is also going to make our platform team, our operations team life very easy. These self-contained jars, we're also going to call them as fat jars or Uber jars because they will have everything packaged, including all the dependencies, all the business logic along with the embedded server. So that's why we call them with various names like self-contained jars, fat jars, or Uber jars. I hope you're clear with the introduction of the Spring Boot framework. If you have any questions, don't worry. While building the microservices in the coming lectures, I'm going to show you a demo of all these. Inside this lecture, let me show you a few funny memes about Spring Boot framework, the microservices. I hope you're clear. The next meme that we have here is someone is trying to direct. When I say that we need to build microservices with the help of Spring Boot framework, behind the scenes, we need to build the REST services. Because at the end of the day, what is a microservice? It is a service that exposes its business logic to other APIs or to external UI application with the help of REST API. Using REST services, we can establish synchronous communication between multiple APIs or multiple services or multiple web applications. Synchronous communication means when a request comes from an external application to my microservice, the external application is going to wait for my response so that it can proceed to the next request. Of course, synchronous communication is not the only option that we have to build microservices. So this is the mostly commonly used approach. In the coming sections of the course, I'm going to show you how to build asynchronous microservices by taking message queues and Kafka as an example. For now, let's try to focus on building REST services. Let me try to introduce a definition of what is REST service formally. REST service works based upon HTTP protocol. Compared to SOAP-based web services, REST services are very lightweight in nature because they can work with the help of lightweight data format, which is JSON. That's why REST is the most commonly encountered approaches to establish communication between two web apps. So whenever we are building services with the help of REST APIs, our web application is going to expose certain endpoints which my client application can invoke by sending a request. So these are the various scenarios where we use REST services. Behind the scenes, it might be communicating with a backend server with the help of REST API. And similarly, if you see the second scenario, two different backend servers are two different microservices. They can also communicate with each other with the help of REST API. And the last scenario that we have is we can build web applications with the help of UI frameworks like Angular, React. And these UI frameworks, they need to fetch the data or they need to store the data inside a backend database. The same, they are going to communicate with the backend server with the help of REST services. I hope you're clear what is REST services. Now let's try to understand what are the various standards that we need to follow while implementing REST services. Because at the end of the day, whenever we're trying to build REST services, we will write a business logic to calculate and to process some data. And our REST APIs, they are going to support CRUD operation on the storage system. For example, inside our REST APIs, we are going to write business logic that supports creating the data, reading the data, updating the data, and deleting the data inside a database or inside a storage system. So whenever we're trying to build APIs that expose these create, read, update, and delete operations to the external applications, we need to make sure we are following the standards of the HTTP methods. For example, whenever you're trying to save the data or whenever you're trying to create the data with the help of your API, you need to make sure you are accepting the request with the help of post method. And similarly, if your API support just reading the data from the storage system and sending the same to the client, then it is just a read operation. For such scenarios, we should use the get HTTP method. And if your API is supporting update operation where a client can update the existing data, then we can use HTTP method put or HTTP method patch. The difference between put and patch is if you're trying to update your entire record or major data inside your table record, then you should use put. Whereas if you're trying to update only a small set of information or a specific column, you should use HTTP patch method to support the update operation. And at last, if the client application want to delete a data inside your application, then you need to expose an API that supports delete operation. And in such scenarios, we should use HTTP method, which is delete method. So please make sure you are following these standards whenever you are building REST services and microservices. And the next standard that you need to follow is you should perform proper input validation on your REST APIs. Because if you consider a UI application, it will have HTML forms, input elements using which you can perform a lot of validations. But coming to the REST APIs, any application can invoke a backend application or a mobile application or an UI application. So that's why you should not rely on the validations that is happening in external system. You should do your own input validation and accordingly process the request. And after the input validations, we should also take care of exceptional handling. Regardless if you are getting a runtime exception or a business exception, you should properly handle it, and you should always send a meaningful response to the clients. Otherwise, you're going to have a very tough time with your clients because they cannot understand what is the issue with your APIs, which data is wrong. If they don't know which data is wrong or why the operation is failing, they will be clueless, and you need to pitch in and make them understand manually, which is a very cumbersome process. That's why always have exceptional handling covering all your scenarios. And the next standard that we need to follow is document your REST services. Inside microservices, we are going to build hundreds of REST services and in some cases thousands of REST services. So whenever you're building such large amount of APIs, it is a good idea or it is a good standard to document your REST services with the help of standards like OpenAPI specifications, Swagger. When you document your REST services well with these standards, your life is going to be easy. Think like your organization has some 1,000 REST API services and it is being consumed by hundreds of client applications from external world. If they all reach out to you, like what is the format of request, what is the validations that you're doing, what is the response format, what are the operations that you support, to explain all this information through a document or through an email or through a KT session or through a knowledge transfer session is going to be very cumbersome, and it is going to be very complex whenever more and more clients are onboarding who are trying to consume your API services. That's why as a bare minimum, please make sure you are adhering to these standards that we discussed here. I'm going to show you how to build the REST services with the help of Spring Boot framework and following all these 3 standards so that you are in a good position to build production ready services inside your real projects. I hope you're clear. Thank you, and I'll catch you in the next lecture. Bye. Finally, we are at a lecture where we'll try to make our hands dirty by creating microservices with the help of Spring Boot framework. Like I said before, creating a web application or building REST service. Similarly, I'm going to give exercise to create loans and cards microservice very similar to accounts microservice. One request that I have here is while you're trying to create microservice based upon the steps that I have discussed, please do follow the same group name, same artifact or same package name, class names that I'm going to discuss inside this course. The reason is many times, many students, they face some issues and they post their issues and their project inside the Q&A of the Udemy course. For me to identify that, if you follow the same naming conventions, it is going to be super easy. And in fact, before posting a Q&A question, you can also compare my code with your code, and this will help you to easily identify the issues if you maintain the same naming conventions that I'm trying to follow inside this course. I hope you're clear. Now coming to the name, I also want to maintain the same name like artifact. So the name also going to be accounts. Description, I want to mention as microservice for accounts. Post that the package name automatically populate based upon the group and artifact. So com.easybytes.accounts. I want to go with the default packaging, which is jar. Since we are trying to build microservice and eventually in the coming sections, we'll containerize our Spring Boot applications. I want to go with the packaging as jar. And the Java version, I want to go with the default Java version here, which is 17. So as of today, 17 is the stable and LTS version available. And please do make sure you are selecting at least Java 17. Please don't select 11 and 8 because the basic requirement for the Spring Boot 3 version and above is Java 17. If you want to use 11 or 8, you need to go with the Spring Boot version, which is less than Spring Boot 3. And in that case, you need to go with the 2.7.13. But I don't recommend that. Always go with the latest Spring Boot version and go with the Java 17 version. So now we have provided all the basic configuration details. Coming to the dependencies, we need to define what dependencies we need for our microservices. The very first dependency that we need to add is web. Since we decided to build REST services, by adding this starter project, my Spring Boot is going to bring all the dependencies and libraries that I need to build web applications, including REST services, MVC-based applications, and it is also going to use Apache Tomcat as a default embedded container. So that's the beauty of starter projects inside Spring Boot. You don't need to define the dependencies manually for all these libraries and dependencies. By just selecting one of the starter project, which is Spring Web, I'm going to get all the dependencies that I need. So let me select this. Post that, since we need some storage supporting database, now I'm going to go with the H2 database. So H2 database is an internal memory database, which you can use inside Spring Boot web applications. It does not require any installation of MySQL servers or Oracle. You can use a simple internal memory database. So let me select that. that, but I'm going to change our microservices from H2 database to MySQL in the coming sections when we start using the Docker containers. For now, let's keep it very simple. We don't want to do unnecessary installations. Post that, since we want to connect with an database like H2 database, we need to have supporting framework. For the same, I want to add the Spring Data JPA as the dependency inside my Spring Boot web application. Using these starter projects, we can store the data into the database, we can retrieve the data. So all the libraries related to database interaction will be available inside the Spring Data JPA. So let me select this. After this Spring Data JPA, I also want to go with the actuator. Like I said before, Spring Boot provides inbuilt endpoints to monitor and manage our application, such as like health of our application, metrics of the application. Since we are building microservice and we want to monitor our microservices without writing any external code, I want to use this actuator dependency. And the next dependency is DevTools. So this Spring Boot DevTools is a starter project which will improve the productivity of the developer. Like you can see, whenever we have this dependency inside our Spring Boot application, it is going to provide fast application restarts, live reload, and configurations for enhanced development experience. Once we start our application, we do some code changes like Java changes or property changes. In such scenarios, we don't have to manually restart the server of Spring Boot. By default, internally, this DevTools is going to restart very quickly by reloading only the changes that I have made. So let me select this as well. And the next dependency is Lombok. So using Lombok, we can avoid all the setters and getter methods that we need to write inside a Pojo class. At the end of the day, all the data that we get from UI application or from other applications will get converted into a Pojo class. And to access the data from the Pojo class, we will use setter methods. So writing these getter and setter methods is very cumbersome and introduce a lot of boilerplate code. So with the help of Lombok, we can reduce that boilerplate code. I'm going to show you the demo in the coming lectures. For now, please add this dependency. And the last validation that I want to add here is validation. Since we decided to follow the standards of performing validations on the incoming request, we need to add the starter project inside our Spring Boot application. So now I have added all the dependencies that I have needed. Please note that whatever dependency that I have added related to Spring Boot DevTools, this will work only for local development. Please don't be under the impression that automatic restarts will happen inside the production as well. That will never happen. Spring Boot team, they are smart enough to activate this dependency only during the local development, but not for the production deployments. I hope you're clear. Now, as a next step, I can click on this generate button, which will generate a Maven application. So let me go to my downloads. You can see here inside my downloads, I have this accounts.zip file. So let me copy this. I'll go to the storage inside workspace folder. I'm going to create a new workspace with the name microservices. Inside this microservices folder, I'm going to create one more folder with the name section 2. Because since I said I'm going to upload all the code that we are going to discuss inside the course as per the sections, I'm going to create separate folders inside the workspace. And the same way, I'm going to upload to GitHub repos so that you have complete code based upon sections inside the GitHub repo. The reason why I'm creating section 2 but not section 1 is right now we are in the section 2. Inside the section 1, we just talked about the microservices introduction, and it is a completely theory section. So now inside this section 2, I'm going to copy these accounts.zip. Let me double click and extract the same. So the file got extracted. I can now remove the .zip file. So here inside this, you can see I have the Maven structure. There is a source folder, there is a pom.xml and other Maven related files. Build a Hello World REST API in the next lecture, but I'm assuming you're super clear with all the steps that we have discussed inside this lecture. I have not discussed about the Java installation, Maven installation, IDE installation, because I'm assuming you are a mature developer who know all those basic concepts, because once you learn core Java, Spring and Spring Boot, then only you will come to learn microservices. With that assumption, I'm not covering all those very basic setup details. If you have any questions, please reach out to me through Q&A. I'll be able to help you. Thank you, and we can continue the discussion in the next lecture. Bye. In the previous lecture, we have created a basic Spring Boot web application. Now let's try to update this basic Spring Boot application with a new REST API that gives a response saying that hello world. The same, if you're already comfortable with all these basic concepts, I would recommend you to fast forward the discussion. That way you won't feel bored. But if you're not aware about all these basic concepts, I would recommend you to follow the discussion. If I try to update this string to hi world and I'm saving these changes and doing a build, as soon as the build is completed, I'm not going to restart the server. I'll just go to the debug and I'll see what is there inside my console. You can see from JetBrains, and also I installed one more theme, which is one dark theme from Mark Skelton. So using these themes, I'm able to get all these look and feel. So you can go to this marketplace and you can simply search for these themes like dark purple theme, and you will be seeing the result, and there'll be an install option for you. Since it is already installed inside my ID, I'm getting a disable option. Once you install this theme, you can enable these and you can search for theme inside your preferences. Once you search for the theme under this appearance and behavior, there is an appearance tab. Just click on that. Under this theme, you should be able to change to whatever theme that you want. And previously, I'm telling to enable the annotations processing because we are going to use a Lombok. For the same, you can also search for annotation here, and you can see this is the annotation processor. So always make sure you are enable these annotation processing. Otherwise, you'll not be able to use all the Lombok related annotations that we are going to discuss in the coming lectures. I hope you're clear. Thank you, and I'll catch you in the next lecture. Bye. In the previous lecture, we have created a simple REST API that says hello to the world. Now, before we try to build other REST APIs, which will help us to expose the CRUD operations to the clients, first we need to make sure that our database related code is completed and it is available for us to interact with the database. As of now, we are using internal H2 database. To use this H2 database, we can define some properties or configurations inside our application. For the same, we need to go to this resource folder. Under this resource folder, we have application.properties file. As of now, you can see it is an empty file. Inside this property file only, we can define all the configurations related to Spring Boot, where we can mention the port number which needs to be considered by the Spring Boot to start the service. We can define database related configurations. We can define message queues related configurations. We can define actuator related configurations. So there are good amount of properties or configurations that we can define inside this file, which will make developer life easy. With the properties that we mention inside this file, Spring Boot is going to do a lot of work behind the scenes. So instead of we writing the Java code or a lot of boilerplate code to handle all those logic, we simply mention the properties inside this file, and Spring Boot is going to take care of connecting to database, starting the server at the mentioned port number, and enabling certain features of actuator. This way, we can achieve many functionality with these properties. But we are not going to write our properties with the format of key and value, which is the default way inside Spring Boot. Instead, we are going to define all our properties with the YAML format. So for the same, what I'm going to do is I'm going to close this application.properties and rename this file from application.properties to application.yml. YML indicates that this file is going to support the YAML format. So YAML is a very famous format, just like XML and JSON. YAML is the latest and mostly used format. The reason why I'm using .yaml format instead of .properties is YAML is very intuitive in nature. We can easily read the YAML file very easily, and the same YAML format is going to be used inside Docker, Kubernetes, or any cloud providers that you go, like AWS, GCP, Azure. Since many places this is being used in future also, definitely I'm confident that Spring Boot will move to the .yaml format. Though right now it is supporting both .properties and .yaml. Since we can achieve more with the help of .yaml format, I'm pretty sure that in future Spring Boot is going to migrate to .yaml format. With that reasons, let's try to define the properties with the help of .yaml. But here you may have questions like, how can I define properties with the help of YAML format? What is the syntax that I need to follow? So you may have many questions. So let me give a quick introduction about YAML syntax. If you see this file, these are the normal property values that I can mention whenever I'm using .properties format. So you can see this is the key and this is the value. So there'll be a key and there'll be a value. The same applies for all other properties. Every property will have a key and it is going to have a correspondent value. So these are the properties, and it is very clear for everyone. There is no big complexity here. There's a key, there is a value. So now let's try to understand how to represent this inside a YAML. YAML is going to work based upon indentation. When I say indentation, you can see whenever I want to define this server.port as a key inside YAML, I need to first mention server followed by colon. Post that, I should immediately give a tab space inside my next row. Like you can see here, I have given a tab space. Then only my YAML is going to consider the key as server.port. And very similarly, for spring.datasource.url, I need to mention spring followed by a tab space, data source colon. And since inside data source, we are going to have the URL, we need to mention the URL again with a tab space. So you can see I have mentioned the tab space here. The advantage of YAML, you can see the spring is repeated unnecessarily inside properties file for every key. Whereas with YAML, it is going to have only once. Inside the same spring, we can define data source only once, whereas in property, you can see it is repeated 4 times. And at last, we reach to the end of the key, which is URL. Once we reach, we need to give the colon, and post the colon, we need to make sure we are giving a single space followed by what is the value. So this is the value that I want to mention. The same I have done for driver class name and username and password. And since I want to give empty password, I have given a single quote with empty value. And very similarly, if you see for this property, which is spring.h2.console.enabled is equal to true, I don't need to mention the spring again. I can straight away come to the same location where the data source is present. And in the same location, I can start the new key, which is h2. This way, I need to maintain this indentation properly. Then only my YAML is going to work. If I screw up this indentation, then my YAML is not going to work. That's why please make sure you are giving the same space, same indentation like I was giving inside the GitHub repo. So let me copy these properties and I can mention inside the application.yaml. So you can see these are the values that I have mentioned inside my .yaml file. I also installed a YAML related plugin inside my IDE. That's why it is able to recognize this file as YAML file based upon the extension that I have mentioned here. So with the server.port, we're telling to the Spring Boot framework to start the port at 8080. This is the default port. Even if you don't mention, it is going to consider the same, but it is a good practice to mention the same inside your applications.yaml file. And when we are going to build other microservice, definitely we can't leave with 8080 because it is already being used by the accounts microservice. So in those microservice, we are going to overwrite to some other port number. Now coming to these properties, all these related to the H2 database. So with the spring.datasource.url, I'm telling to the Spring Boot framework that this is the endpoint details where my application can connect to the internal H2 database. So JDBC H2 mem testdb. So this is the value that we need to give. And the driver class name, we need to give org.h2.driver, and username SA. This is the default username. If you want, you can change. And the password also, I want to go with the default password, which is an empty value. Now, with the help of the spring.h2.console.enabled, I'm telling to the Spring Boot framework to enable the H2 console so that I can log in into this H2 console from my browser and I can see all the tables and records that are inserted or created into my internal H2 database. And very similarly, we need to mention other properties like spring.jpa.database platform. And the database platform that we are using is H2 Dialect. And with this spring.jpa.hibernate.ddl auto as update, we are telling to the Spring Boot framework, if there are no tables created inside my internal H2 database, please go ahead and create them based upon the SQL instructions that I'm going to provide automatically during the startup. So that's the purpose here. We don't want to create the tables every time manually inside our internal H2 database. We want that process to be automatically happen when server is being started, because H2 database is an internal memory database. Whenever you shut down the server, all the data and all the tables that you have created will be wiped off. That's why to overcome the challenge of creating the tables and data manually every time, we can provide some SQL scripts. Based upon that, my Spring Boot framework can automatically create these tables behind the scenes during the startup. And at last, we also mentioned spring.jpa.showSQL as true. With this property, we're telling to the Spring Boot framework, please print all the SQL queries that you are going to execute against to the H2 database on the console. And with this, the developers can see what are the queries that are being executed behind the scenes by the Spring Data JPA framework. And these queries are going to help them during the debugging process. I hope you're clear with these properties. Please make sure you're also using this YAML format. This format is going to help you to work on multiple products like Docker, Kubernetes, and cloud environments. So let me save these changes. Now, like I said, during startup, we want some tables to be created so that we can store the data inside these tables. For the same, under this resources folder, you need to create a new file with the name schema.sql. Whenever you want to create the tables, columns, you need to define a file with the name schema.sql. Whereas if you want to create data with the help of insert scripts or update scripts, you can define a file with the name data.sql. For now, I just want to create the tables inside my internal H2 database. So now inside this SQL file, I'm going to paste a few scripts. So these are the scripts that I have pasted just now. I'm not typing all of them in front of you just to save some time here. Please get these scripts from the GitHub repo, and you can also paste inside your schema.sql. The same you can do for application.yaml file as well. Throughout the course, I'm only going to type very important code in front of you to save some time. You can always pause the video. You can always get the code from GitHub repo, or you can type the code by seeing at the screen, but please make sure you are passing the video. So I'm doing this so that we can learn more with less time, because if I start typing all the hundreds and thousands of lines of code that we are going to discuss, definitely the length of the course is going to become more, since I want to teach you more with less time so that you can learn quickly. That's why I'm following this strategy. I hope you understand. So now let me save these changes and do a build. Once the build is completed, since my application is already started and we have DevTools inside our class path, my DevTools might have restarted the server. You can see this time my server restarted in 1.237 seconds, and my Spring Boot framework considered all the URL details that we have given for the H2 database. And you can see by default, the Spring Boot framework is going to expose the H2 console with this path, which is H2-console. So let me try to access this H2 console in the browser. So I need to go to the localhost 8080 followed by H2-console. And here I'm trying to access it. You can see you'll get this page where you need to enter all your driver class, JDBC URL, username and password. By default, these values will get automatically populated. Please make sure the values are matching with what you have mentioned inside the applications.yaml file. So the username is SA, password is empty. I'm just clicking on this connect. With that, this is the H2 console where you can see there are two tables created with the name, accounts, and customers. So my accounts table has columns like customer ID, account number, account type, branch address, created date, created by, updated at, and updated by. Very similarly, if I click on this customer, it has columns like customer ID, name, email, mobile number, created at, and updated by. So these tables are created based upon the scripts that we have provided inside the schema.sql file. So if you try to understand the scripts, first I'm trying to create a customer table where we're trying to save the name of the bank customer, what is his email, what is the mobile number, and a few metadata related columns like created at, created by, updated at, and updated by. So these four metadata columns are going to present in each of the table that I'm going to create inside this course. So this is the another standard that you need to follow inside the real projects. These columns will help us who created the data, at what time the data is created, and who updated the data at what time. I hope you understand. For this customer table, a primary key is going to be customer ID column, and it is going to be automatically incremented whenever I'm trying to insert a new record into the database. So this is what we're trying to achieve with this customer table creation. And the table will be created only if it not existed in the database. Now coming to the accounts table, you can see I'm mentioning the customer ID column, and there is going to be a foreign key link between these customer and accounts table with this customer ID column. And inside this accounts table, we are going to have a column with the name account number, which will act as a primary key. And post that, we'll also have columns like what is the account account type, whether the account type is saving account or current account, and what is the branch address, followed by metadata columns. So I'm just trying to keep the things simple so that we can focus more on the microservice concept rather than creating complex tables, complex mappings, and do a lot of unnecessary things. I hope you're fine with that. With this, we set up the H2 database with the help of the schema.sql file and with the properties mentioned inside the application.yaml file. In the next lecture, let's try to build the code with the help of Spring Data JPA that will help us to interact with this H2 database and tables so that we can start leveraging this database for insert data, for reading data, for updating and deleting the data. Thank you, and I'll catch you in the next lecture. Bye. In the previous lecture, we have created these two tables with the names, accounts, and customer inside our internal H2 database. The same database structure, the same tables and columns we are going to use even when we migrate from H2 database to MySQL database in the coming sections. Right now, we have the database and the tables inside it. As a next step, we need to write Java code to interact with these tables so that we can start saving the data into these tables. We can read from them. We can update and delete the data from these tables. For the same, inside our pom.xml, we already added a library with the name Spring Data JPA. So this is the library under which we have many interfaces and classes which will help us to interact with the database tables. Whenever we want to use this framework, first we need to create the Pojo classes representing each of the table that I have inside my database. For the same, I'm going to create a new package, and the package name is going to be entity. Since inside this entity package, I'm going to store all the entity classes of my database. That's why I have choose this name. As of now, if you look at the table structure that we have, there are 4 columns that are going to be present in each of the tables that we are going to create. These 4 columns are the metadata columns that we maintain in each of the table. So it is a good idea to create a separate super class that will maintain the details of these 4 columns. That's why inside this entity package, first I'm going to create a new Java class with the name base entity. Inside this base entity class, I'm going to create 4 different fields, each representing one of the metadata column. The very first one is private local date time, and the field name is going to be created at. Please make sure this field name is matching with your column name that you have created inside the table. So created at, you have to remove the underscore, post that, convert the first letter of the second word to capital letter like we are seeing here. This way, we don't have to tell to the Spring Data JPA framework to which column this field is mapped inside my database. The next field is private string. For this field, I'm going to mention the field name as created by. So this represents the second metadata column that we have, which is created by. Very similarly, I'm going to create the next 2 columns and rename these to updated at and updated by. Now, as a next step, we are supposed to create the getter and setter methods for these fields, and creating all those getters and setters will be a very cumbersome process. And at the same time, the code looks very lengthy, which we don't want. That's why we need to use our Lombard related annotations. The very first annotation that we need to mention on top of this class is @getter. So when we mention this annotation, behind the scenes, my Lombard library is going to generate the getter and setter. The same I'm doing for the setter with the help of these @setter annotation. And if needed, we can also mention the toString annotation, which will help us to convert these base entity object to the string format. So once we define all these Lombard related annotations, we should be good. So let me save these changes. Now, if I try to show you the methods present inside this class, you can see there is a getter methods for each of the field, like get created at, get created by, and very similarly, we have setter method and toString method also created by the Lombard annotation behind the scenes, which means you will not be seeing these getters and setters inside your code, but behind the scenes, Lombard is going to do the magic of generating them inside the bytecode of your classes. That's why whenever you are seeing the list of the methods inside your classes, you're able to see all these methods. You can uncheck these inherited members and you'll be able to see all the methods which are specific to this class only. I hope you're clear. Now, since we are trying to leverage this base entity class for all the other entity classes that we are going to create inside our project, we need to mention an annotation which is @mapped superclass. This indicates to the Spring Data JPA framework that this class is going to act as a superclass for all my entities wherever I'm trying to extend this base entity class. So once we mention these details, we can also mention one more annotation on top of each field, which is @column. Using this @column annotation, we can mention what is the column name inside the database that we're trying to map to this field. But since the column name and the field names are matching, we don't need to mention the column name manually with the help of these @column annotation. So what I'm trying to mention here is I'm going to mention updatable is equal to false. The purpose of this updatable is equal to false is whenever a record is being updated inside the database table, I don't want this column to be considered by the Spring Data JPA to populate the value and to update the value, which means this field will not be updated whenever I'm trying to update my record, because I only want to maintain this created at time to represent what is the original time when my record is inserted. Let me do the same for created by also. Now, very similarly for the updated at, I'm going to mention the insertable is equal to false. Just like how we have updatable is equal to false, we also have insertable is equal to false. This tells to my Spring Data JPA framework, please do not populate or update these 2 columns whenever it is trying to insert a very new record inside the database. Of course, this makes sense because while we are trying to insert the record very first time, why do we want to update these 2 columns? We need to maintain them as null values. So now my base entity class is ready. So let me go to the entity package, and here I'm going to create a new class which represents customer table. That's why I'm trying to create a class with the same name, customer. So here, the very first annotation that I'm need to mention is @entity. So this tell to my Spring Data JPA framework, please treat this Pojo class as a entity representation or an Pojo representation for my table with the name customer. So if you see, the table name will match with the class name that we have. So this is matching. If it is not matching, and if you are trying to use a different class name, then you can use the annotation which is @table. And to this table annotation, you can pass the name parameter to which you can mention whatever table name that you have inside the database. Since right now the class name and table name is matching, I don't want to use @table annotation. First I want to create a field with the name private long customer ID. So this is going to hold the primary key value inside my database, followed by private string name. And this name field is going to hold the name of the customer. And very similarly, private string email, followed by private string mobile number. So with this, we have created all the fields with the same names like we mentioned inside the table, like customer ID, name, email, mobile number. Now, since we also have metadata related columns inside our entity, we need to extend the entity class that we have created previously, which is base entity. So once we define these details, all the fields that we have inside the base entity will be considered by the Spring Data JPA framework whenever it is trying to insert a new record or update a record or delete a record. As a next step, we need to also mention the Lombok annotations like getter, setter, toString. And very similarly, I'm also going to mention all aux constructor and no aux constructor. With the help of all aux constructor, my Lombok is going to generate a constructor which accepts all the fields that we have inside this Pojo class. And very similarly, with the no aux constructor, it is going to generate an empty constructor. The reason why I'm mentioning these two annotations is in future, when we're trying to leverage this customer entity class, we need to create the object of this entity class. And when we're trying to create the object, obviously we need the constructor like all aux constructor and no aux constructor. That's why I'm mentioning here. Now, like I said, this is going to be a primary key column value. But how do I communicate that to the Spring Data JPA framework? There are 4 fields inside this class, but this field is going to represent the primary key value. So to communicate the same, we need to use annotation which is @ID. Now I told to my Spring Data JPA that this field is going to represent as a primary key, but are we going to provide the primary key value manually to the Spring Data JPA framework, or we want the Spring Data JPA framework to automatically generate a primary key value whenever it is trying to insert a new record into the table? It is a good idea to give the responsibility to the Spring Data JPA framework. For the same, we need to mention 2 annotations like you can see here. These 2 annotations, which is @generated value and @generic generator. Using these 2 annotations, we are trying to tell to the Spring Data JPA framework, please automatically generate the primary key values. That's why I'm mentioning the strategy as generation type dot auto. Auto indicates automatic. And what is the generator value? Generator value that I'm mentioning is native. The same native name I have created here with the help of @generic generator annotation. For the second annotation, I'm passing the strategy as native. With the native strategy, I'm telling to the Spring Data JPA framework, whatever database that I'm using, please try to generate the sequence number or the primary key value based upon the native style of my database. For example, if I use MySQL database as my backend database, my Spring Data JPA framework is going to leverage a native strategy which is specific to MySQL database. So this is what we are communicating with these 2 annotations. So please make sure you are mentioning these 2 annotations inside your code as well. And like I said before, we can also mention @column annotation. And to this column annotation, we can pass what is the column name. Here the column name is customer ID. So the field name and the column name is matching. I'm again mentioning this so that you'll have a reference in future. I'll also mention the same for mobile number. Like I said, even if you don't mention this @column annotation, it is going to work perfectly because the column names and field names are matching in our scenario. I'm just mentioning for your reference so that in future you are aware of these @column annotation. So now I need to create one more entity class representing the second table that I have, which is accounts. So let me copy this customer entity and paste inside the same package. For this new entity, I'm going to keep the name as accounts. So let me create this new class. So to this accounts entity class, we are fine extending the base entity and we are fine with all those annotations. And inside this entity class, customer ID is not going to be the primary key value. It is only present to establish the link between accounts table and customer table. So let me remove all those ID values. Post that, I'm going to create a new field with the name private long account number, and account number is going to act as a primary key value inside my table. That's why I need to mention @ID. And on top of this field also, I can mention @column just for your reference. Like this is going to represent the database column, which is count_number. Let's check if this is matching with the schema.sql. Yes, this is matching. The next field that I want to create is account type. So to this field also, I'll mention @column. The strategy that I'm using right now to mention this @column is wherever the column names has underscore inside them, I'm just mentioning the @column. But like I said, this is completely optional if the column name and field names are matching, ignoring the underscore value. So this is matching with the account type. Now let me do the same for branch address. So the field name is going to be branch address. And here I'm not mentioning any annotations related to generate the primary key value automatically. The reason is I am going to write a small logic inside my REST API service to generate the account number manually and assign the same into the database. We don't want our bank account numbers to start with sequence numbers like 1, 2, 3, 4. That won't look good. Account number usually will be 10-digit number. That's why as a developer, it is my responsibility to generate an account number. And with that reason, I have not mentioned the annotations related to primary key generation like we mentioned inside the customer table. I hope this is clear. With this, we have successfully created entity classes representing each of the table that we have created inside our database. Now, as a next step, we should also create the repository classes representing each of the table, because with these entity classes, we can only store our data into the entity Pojo class, but we need some logic that will take the object of these entity classes and interact with the database tables that we have created. For the same, we need to create the repository interfaces inside our web application. So I'm trying to create a new package here. The package name is going to be com.easybytes.accounts.repository. Inside this repository package, I'm going to create a new interface, and the interface name is going to be customer repository. And using this repository, I'm going to interact with my customer database table with the help of Spring Data JPA framework. So let me create this customer repository. Now, on top of this interface, I'm going to mention an annotation, which is repository. Whenever I'm mentioning this annotation on top of my interface class, behind the scenes, my Spring Data JPA framework will create a bean implementation of this interface based upon the configurations that I'm going to provide. So this is just an empty interface. The Spring Data JPA framework cannot create an object or bean from it. In order to bring the magic of Spring Data JPA into this interface, we need to extend a class from the Spring Data JPA framework, which is JPA repository. To this JPA repository, it is going to accept two parameters. One is what is the entity class, which is going to be handled by this repository class. And the second parameter is what is the data type of your primary key field inside your entity. So if you open this customer table, the primary key data type is long. That's why we need to mention the same here. So whenever I'm creating a interface with @repository annotation that is extending JPA repository, behind the scenes, my Spring Data JPA framework is going to generate the runtime code by providing large many methods. If you see, all these methods are coming from the framework. Like I can execute CRUD operations like find, delete, update, and insert. So these all find methods will help me to find the records from the database. Similarly, we have save methods to insert and update the records inside the database. This way, I'm able to get all these methods from the Spring Data JPA framework without I writing any SQL manually inside my business logic. I'm going to show you the demo of these repository interfaces in the coming lectures. For now, please note that this JPA repository is coming from the Spring Data JPA framework, and this internally extends list paging and sorting repository and other interface like query by example executor. Like I said, if you're not aware of the Spring Data JPA framework in detail, please look for an Spring course that explain more about the Spring Data JPA framework. For now, please note that with the help of the JPA repository, we don't have to write any code to execute the CRUD operations on our table, which is customer. So now very similarly, I'm going to create one more repository interface, and this repository interface is going to be accounts repository. The only change that we need to do here is to update the entity class name. So the entity class name is accounts, and it is also having a primary key value that supports long. So we should be good with this long parameter value. So like you can see, these interfaces are empty as of now. And with the help of these interfaces, we can invoke the methods from the framework to perform the CRUD operations, which I'm going to show you the demo in the coming lectures. With this, inside this lecture, we have created the entity classes for our database tables. And also we have created the repository interfaces using which we can interact with the database tables by using the methods available inside the Spring Data JPA framework. I hope this is all clear to you. Thank you. And I'll catch you in the next lecture. Bye. In the previous lecture, we have created entities representing each of the database table that we have. So with these entities, we are supporting inside our web application to create new account customer details, to fetch the account and customer details, to update and delete these details. What if one of the client application, they want both your accounts and customer data together in a single request? Do you think we can send two different objects as a response? Of course not. We cannot send them two different objects. We can only send a single object inside a response. Maybe you can think like we can create one more entity or Pojo class, and inside them, I can try to create the fields of accounts and customer. That way I can embed both these two classes inside another class. That's one of the basic approach, but we should not do that. The reason is all these entity classes, they are related to the database layer. You may ended up into various scenarios where you may want to send the data in various formats or in various combinations. That's why we should never touch these database related entity classes. They should always clearly and purely represent the database tables. So to overcome this challenge, we have a standard with the name DTO pattern. So let's try to understand what is this DTO pattern. DTO means data transfer object. What is this pattern is recommending is whenever a client is trying to communicate with a backend application to get the data, we should follow the DTO pattern, which is a desired pattern that will allow to transfer data between different parts of your application. For example, inside my application, I can have a database layer, presentation layer, service layer. So to flow the data between multiple layers of your web application, we should use these DTO pattern. And inside these DTO patterns, we should create the DTO classes, which holds the fields that you want to transfer to and fro from the different layers of your application. So here, let's take an example to understand this. On the right-hand side, I have customer entity class and accounts entity class. And inside these, we have these fields which represent columns inside the database. I didn't mention metadata columns here just to save some space, but these customer and accounts, they represent the database entities. And some client, they may request you to send both the customer and accounts in a single request. In such scenarios, what you can do is we can create a DTO class with the name like customer details DTO. And inside this DTO class, you can define all the fields that your client is asking from these entity classes. Once you define a DTO class, in between, you can write a mapper logic or aggregation logic that will take care of converting all your field values from DB entity to DTO class. So this is just a small piece of Java code that we need to write. I'm going to show you the demo of these DTO classes and pattern in the coming lectures. This way, my client applications who are using web application like with the help of HTML page, or who are trying to invoke my REST APIs with the help of other backend APIs, they can always request whatever data that they want from my database tables. Instead of I sending the data with the help of my database entity Pojo classes, I should rely on the DTO classes. And following this pattern, we have various advantages. The very first advantage is it is going to reduce the network traffic. Think of a scenario if you don't have this DTO pattern, and if your UI application or if another client API, they're trying to ask you, provide me both customer and accounts table data. So in that case, you'll ask them to send the two different requests, one for customer and the other one for accounts, which is unnecessary. Whereas with a DTO pattern, they'll make a single request and you'll have a mapper logic, which will take care of combining the data from the customer and accounts and transferring into the customer details DTO class. And the same, you'll be responding back to the client applications. And the second advantage that we have is encapsulate serialization. So these DTO classes, usually they represent only the data that they carry. We're not supposed to write any other business logic inside these DTO classes. Apart from these data fields, we can also write logic related to the serialization. When I say serialization, some clients, they may ask you to send the data as an XML or as an JSON format or an YAML format. So whatever serialization format that they need, you can always write that logic inside your DTO class. Otherwise, you'll end up spreading or writing that serialization format in many places of your application, which is going to be again a cumbersome process to maintain whenever there is a serialization format is changing in future. And the last advantage that we have with the DTO pattern is it will decouple the layers. With the help of this DTO pattern, your presentation layer is going to be decoupled from the data access layer. What is the meaning of decoupling between presentation layer and data access layer? This means your presentation layer, like your client applications, they never know what is the database entities, what is the fields that they hold, what kind of data that they hold. They don't have to worry. And if there is anything changing inside the database entities, that will never impact the client applications, because client applications, they always work with the help of DTO class. Suppose think like in future, you are introducing new column inside the DB entity, and the same will be reflected inside your DB entity classes. If it is not required to the clients, you don't need to send that to clients and you don't need to update the DTO class. This way, the DB layer and presentation layer or client layer is always decoupled with the help of DTO pattern. I hope you're clear what is DTO pattern. So as a next step, what we have to do is for each of the DB entities that we have created inside our web application, we need to create a correspondent DTO class so that we can send the data or response to the client applications when they invoke our REST APIs or microservices with the help of these DTO pattern and DTO classes that we are going to create. I hope this is clear. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let's try to create the DTO classes representing each of the entity classes that we have inside our accounts microservice. Before I try to do that, I just wanted to reiterate one more time. If you're clear about all these basic concepts that we typically follow whenever we're trying to create REST APIs, please try to watch the video at higher speed so that you won't get bored. I'm trying to cover all these basics so that these concepts will help the students or junior developers who are not aware about all these basic concepts. But I promise you, there is a lot of interesting and exciting stuff ahead once we build all these microservices like accounts, cards, and loans. We are going to explore a lot of interesting topics. So brace yourself. Now coming to our DTO pattern, I'm going to create a new package here, and the package name, I'm going to keep it as DTO. And inside this DTO package, first I'm going to create an DTO class with the name accounts DTO. It is always advisable to end your DTO classes with the name DTO. That way you can always know the difference between a DTO class and a normal Spring Data JPA entity class. So inside this DTO class, what I'm going to do is I'll go to accounts. I will take all the fields that I want to send to my client application. So I don't want to send the customer ID to my client application. Why do they want the ID which is specific to my internal database? So these kind of data filtering also we can do with the help of DTO pattern. That's why I'm ignoring this customer ID into my DTO class. So what I can do is I can take this account number, account type, and branch address, and I can mention them inside my DTO class. I'm removing all the code related to the JPA. So these are the three fields that I have created inside my DTO class. As a next step, we need to create the getters and setters for these class also. So instead, I'm going to use a lombok here. Instead of mentioning @getter, @setter separately, I can mention an annotation which is @data. So if you open this data annotation, you can see this is a combination of getter, setter, required aux constructor, toString, equal and hash code, and value. So whenever I'm using this annotation behind the scenes, it is going to generate all the getters, setters, equals method, hash code method, toString, everything it is going to generate. The reason why I have not used this @data inside our entity classes is I don't want to generate the hash code or equals code method for our entity classes, because sometimes it is going to create issues with the Spring Data JPA framework. With that reason, I have not used the @data on top of our entity classes. Now, as a next step, I'm going to create a next DTO. So let me copy this class and paste it again. And I'm going to rename it to customer DTO. So here inside the customer DTO, I want to use @data annotation, but I want to maintain the fields related to customer. Like I don't want to send the customer ID. I just wanted to send name, email, and mobile number to my client applications. That's why I'm going to take these fields and mention them here. And I'm removing the JPA specific annotations here. So with this, we have the customer DTO also ready. And I'm not creating any DTO class, which is a combination of customer and accounts entity class, because for now, I'm not going to have that scenario inside our REST API. But definitely when we progress in the coming sections, we are going to have a different DTOs, which will aggregate the data and send the same to the client application. After this customer DTO and accounts DTO, I want to create two more DTOs that will help me to send the response to the client application in certain scenarios. Think like my client application gave a request to save the data into the database. My REST API or my microservice will accept the data, will store the data inside database. So as a response, I may want to send a successful response or a error response. So in such scenarios, I can't use these DTOs because they don't have any fields representing the status code and status message inside my response. So for the same, I'm going to create first a new DTO class, and the DTO class is going to be response DTO. So let me create this class. Inside this class also, I'm going to mention @data annotation. Apart from @data annotation, I'm also going to mention all args constructor annotation. The reason why I'm mentioning this all args constructor is by default, the data annotation will not generate a constructor which accepts all arguments present inside my DTO class. That's why I'm creating this. In future, I need a constructor that accepts all arguments as a input parameters. That's why I have mentioned this annotation. Now, I want to mention two different fields here. The very first one is private string status code. So this is going to send what is the status code to my client applications. Like I can send 200 if it is successful. Or similarly, I can also send other status code like 500, which represent there is an error. Very similarly, I'm going to mention private string instead of status code. I'm going to mention status MSG, which is status message. With these two fields, we're going to send what is the status code and status message inside the response, using which my client can easily understand whether the given operation is successful or not. Now, just like normal response DTO, I also want to build a error response DTO, which we can use whenever there is an error or exception happen inside the microservice. So the class name is going to be error response DTO. And inside this DTO class, I'm going to mention the same annotation, which is @data and all args constructor. And we're going to create 4 fields here. The very first one is private string API path. So this represents what is the API path that my client application trying to invoke. I want to send inside the error response also that you invoke this path and it failed due to so and so error code and the error message and so error time. That's why let me try to create other 3 fields that we need. Private HTTP status, what is the error code? So I'm going to send the error code, which is of type HTTP status, to the client applications, sharing what is the reason that the API invocation failed. Now after error code, I'm going to create a new field with the name error message. And at last, I'm going to create a new field with the name error time. So this is going to return local date time. So with these 4 fields, my clients will have all the information like which API they try to invoke, what is the error code that they receive, what is the error message, and at what time the error happened. This will also help the developers on the client side to debug the logs inside their system, and accordingly, they can try to debug the issue. With this, we have created all the required DTOs for our accounts microservice. We can build the mapper logic or aggregation logic based upon the needs in the coming sections. But for now, we have not implemented DTO pattern completely inside our microservice. We just created DTOs, we created entities. So there should be some mapper logic that we need to build, and we are going to build that as we are making progress inside this course. Before I try to close this lecture, I want to highlight that this DTO pattern is initially recommended by Martin Fowler inside his blog. So like you can see, he gave a description why we should follow this data transfer object pattern. And he also gave a logic. Suppose inside a database, there is an album table and artist table, which holds a title and name. And if one of the clients, they want both title and the name of the artist inside the response, then definitely we will have an album DTO, which will hold both title and artist. All the data inside the entities will be mapped to DTO with the help of these assembler logic or mapper logic in between. And if needed, we can also write some serialization specific logic inside our DTO classes. And in some project or in some organizations, they call these DTO objects as value object or transfer object. So regardless the name that they are using, if they're using different POJO classes instead of database entity POJO classes to transfer the data between multiple layers of the application, then they are following the DTO pattern. I'm going to mention this URL inside the GitHub repo page. And at the same time, I'm also going to attach this URL link to this lecture. If you are interested to read this page, feel free to do the same. With this, we have successfully created DTO classes inside our accounts microservice. Thank you, and I'll catch you in the next lecture. Bye. Are you excited to build the actual business logic? Now is the time to build the actual business logic inside our accounts microservice. Inside this lecture, I'm going to build a REST API that will support the creation of a new account and new customer details inside our H2 database that we are maintaining. Please watch this video carefully because I'm going to cover lot many standards, including exception handling, service layer logic, and how to leverage the DTO pattern. So in order to create a new REST API service, we need to go to the accounts controller because inside this controller class only, we have created previously a say hello API. And right now we don't need this. Let me delete this say hello API. In real projects, whenever we are trying to build REST APIs, it is always recommended to maintain a prefix API path, which is common for your entire REST APIs present inside your controller class. For the same, we need to mention the annotation, which is request mapping. To this annotation, I'm going to pass the path parameter. And to this path parameter, for now, I'm giving the prefix path as API, which means any REST API that I'm trying to implement inside this controller class, it is going to have this prefix path inside API. If needed, few projects, they also maintain the version number of the API like V1 or V2 But right now, since this is not a real project, we don't need to maintain these versioning inside our API paths. That's why I'm just going to mention the prefix as /API. After this, it is also good practice to mention what is a return type data format from your REST APIs. So we are going to support the return type data type as JSON. That's why we need to mention producers is equal to media type. Please make sure you are selecting the media type from the Spring Framework.http package. Using this media type, we can invoke a constant which is application JSON value. Like you can see, I'm just selecting the JSON value. So this confirms to my Spring Boot framework that the REST APIs that I'm going to implement inside this controller or inside this microservice, they are going to support the response type of type JSON. So now I'm going to create a method that supports create operation. So public response entity, and inside this response entity, I'm going to send the response DTO that we have created previously, and the method name is going to be create account. And to this create account method, I'm going to accept the request from my client applications. That's why I need to mention the request to body. With the help of request to body annotation, whatever my clients are sending inside the request body, the same will be mapped into the Pojo class that I'm trying to mention after this request body. The Pojo class that I'm going to mention here is customer DTO. This means anyone who is trying to invoke my create account method, they need to pass the input by following the data present inside this DTO. They need to pass what is the name of the customer, what is the email of the customer, what is the mobile number. Now, on top of this method, I need to mention the @post mapping annotation, because since this is a create operation, like we discussed, we need to use HTTP post method. And to this post method, the API path that we decided to improve our REST API documentation further. But the same, first, I want to target the top section. So as of now, you can see this section does not have any much information about what is the purpose of my REST APIs that I'm trying to expose here. What is the summary? What is the description? Is there any? I hope you are successful at building the loans and cards microservice. If not, don't worry. I'm going to explain about this microservice very quickly inside this lecture, but please download the code from the GitHub repo and set up the same inside your IDE as well, so that at least you can test these microservices with the help of Postman by passing some input and validating all the operations are working or not. Inside this lecture, first, I'm going to explain you loans microservice. First, like you can see inside the pom.xml, I have followed all the same naming conventions. Like I have used this version, and group ID is com.easybytes. Artifact ID for loans is loans, whereas for accounts we have used as accounts, and the name is also going to be loans. And this is the description. And I have used Java 17 version. And you can see I have used the same Maven dependencies like Actuator, Spring Data JPS, Starter Validation, Spring Boot Starter Web, Dev Tools, H2 Database, Project Lombok, and the class we have Spring Doc OpenAPI Starter Project. And by default, you will get the Spring Boot Starter test whenever you're trying to create a Spring Boot web application. So post this, we can go to the application.yaml to validate the H2 related changes. So inside the application.yaml, for loans, please make sure you're using the port 8090. Throughout this course, for loans, the port we are going to use is 8090. That's why please don't try to give different port number. Otherwise, you may need to change lot many configurations, Docker files, Kubernetes files in the coming sections. And we have provided the H2 related properties like what is the URL, driver class name, username, password, H2 console enabled as true, and database platform as H2 Dialect, and DDL auto as update and show SQL as true. This week, everything copied from accounts microservice, only the port number will change, which is 8090. Now I'm opening the schema.sql. You can see inside loans microservice, I'm going to have only a single table with the name loans. The reason why I'm not creating a customer table is I already created a customer table inside the accounts microservice. What I'm going to do is inside all the microservices, I'm going to have a mobile number, and using the same mobile number of the customer, which is created inside the accounts microservice, we can create a loans record. We can also create a cards record inside the cards microservice. So you can see the structure of this loans database table is the loan ID is going to be primary key, post that mobile number followed by what is the loan number, which we are going to generate using a business logic. What is the loan type? What is the total loan amount? What is the amount paid so far? What is the outstanding amount? And these are the 4 metadata columns. Now for this database table, we need to create the JPA entities and repositories. If you can open these entity package, as usual, there is a base entity class with all the metadata related columns. And along with that, I have also mentioned the auditing related columns like created at, created by, last modified date, and last modified by. So next, I'll go to the loans entity. So inside this loans entity, very similar to accounts, this is also going to extend base entity. And since loan ID we decided to have as a primary key, we are giving this responsibility of generating the primary key value every time to the Spring Data JPA framework. That's why we need to mention these 2 annotations. And with the help of this @ID, we are making sure this is acting as a primary key. And post that, these are the fields representing each of the column inside the database. And I have not used @column because the field names and the column names are matching. For that reason, we don't have to mention the @column annotation. As a next step, we need to make sure we are creating DTOs for these entities. So like you can see, error response DTO, which is very similar to accounts. Coming to the loans DTO, inside this, we have fields like mobile number, loan type, total loan, amount paid, and outstanding amount. Since I don't want to expose the primary key column, which is loan ID, that's why I have not mentioned the loan ID related field inside the DTO. I only want to send business related information, but not technical information to my clients. That's one of the advantages that we have with the DTO pattern. Apart from these fields, you can also observe that I have also used the OpenAPI specification related annotations like @schema. And very similarly, I have also mentioned validations with the help of annotations like not empty, pattern. And here there are new annotations like @positive, which will make sure we are accepting only positive numbers. Even 0 also is not allowed whenever you're using positive. And very similarly, we also have an annotation with the name positive or 0. Whenever we are using this validation annotation, that means we are okay to accept 0 and greater than 0 values, but not the negative numbers. I hope you're clear. After this, as usual, we need to go to the controller class. Inside the controller class, first I make sure I have used the @rest controller annotation followed by what is the request mapping. For this also the prefix is going to be API, and these APIs are also going to produce JSON format. After that, you can see I have injected loan service related bean into this controller, and there are 4 different APIs inside this controller class. There is a create loan, which will accept the mobile number. Based upon the mobile number, it is going to create a new loan. Please make sure you are giving the same mobile number that you have used for accounts microservice, because in coming sections, using the same mobile number, we are going to fetch all the records present inside the accounts, loans, and cards microservice by using various concepts available inside the Spring Cloud project. So this is the story of create loan. Now coming to the fetch loan details, using the mobile number, it is going to fetch the loan details from the database, and it is going to return the same to the client application. And post that, we also have update operation with the name update loan details. And this is going to accept a loans DTO as an request body. And using this, all the loans details will be updated in the database. And once the update operation is successful, we are going to return 200. Otherwise, we are going to return the status as expectation failed with the status 417 and the corresponding message. And at last, we also have delete operation with the name delete loan details that is going to accept mobile number as the input. And based upon the input, we are going to fetch the loan details and delete them. Once the delete operation is successful, we are going to send the 200 response. Apart from this business logic, I'm also assuming you observe these OpenAPI specification related annotations like API response, operation. So this is going to be very similar to what we have discussed for accounts microservice. Only make sure you are changing the summary description, which is specific to loans microservice. As a next step, let's go to the loan service IMPL. So here I'm going to open the IMPL, and this implementation class is going to implement an interface which is iLoan service, and this is very similar to iAccount service. So it has 4 methods like create loan, fetch loan, update loan, and delete loan. So these abstract methods we have implemented inside this implementation class. And for this class, we have auto-write the loans repository. If you go and check the loans repository, here we have defined 2 custom methods like find by mobile number and find by loan number. Like, the primary key inside the loans is loan ID. So whenever we have such scenarios where we want to fetch loan records based upon mobile number and loan number, we need to make sure we are using these custom methods that we have defined inside the loans repository. Now going to the loan service IMPL, here we have create loan. And inside this create loan, first we are trying to understand if there are any existing loan details with the given mobile number. If there is any, we are throwing an business exception, which is loan already exists exception. So this is very similar to account already exists exception. If there is no loan available with a given mobile number, we are going to create a new loan by calling the save method. And to this save method, we are invoking this create new loan method, where all the details for the new loans is going to be populated. You can see I'm generating a random 12-digit number here. Post that, I'm setting the same loan number to the loan object, followed by what is the mobile number, what is the loan type. By default, I'm setting the loan type as home loan, and the total loan by default, I'm trying to give $100K or $100K, whatever currency you are using. I'm not sure if you are aware of this format where we can use underscore inside numerical values. This is a new feature that got introduced in Java 7 or Java 8. So to improve the readability, we can mention underscore values like this, but behind the scenes, when my JVM is trying to convert this Java code into byte code, it is going to remove these underscore values. This is amounts that I'm trying to provide for the total loan amount. And initially the amount paid is going to be 0, and outstanding amount will be 100K minus 0, which will be the same, which is new loan amount. So once the loan is created, save operation will be successful. And if you go and observe right now, fetch loan method here, based upon the mobile number, we are trying to fetch the loan details. If there is no loan details, we are throwing resource not found exception. But if there is a loan available, we are going to get the object and the entity object form, but we need to convert that into a DTO form. That's why I'm using this loans mapper class and invoking this map to loans DTO. So just like how we have accounts mapper, very similarly here also we have these map methods, which is going to accept loans entity, and it is going to convert to loans DTO. So this way the fetch loan method is going to work. And coming to the update loan, we are trying to fetch the loan details with the help of loan number. Since loan number cannot be changed, we are trying to fetch the details with the help of loan number. Once we fetch the details, we'll try to convert that into loans entity object with the help of this mapper map to loans. So the input is going to be the received DTO, and the destination object is going to be whatever we fetched from the database with the help of loan number. If you're not able to identify any records, we are going to throw this resource not found exception. At last, we are going to invoke the save method. Since there is already an record inside the database with the given primary key value, the save method internally is going to do the update operation instead of insert operation. At last, we are going to return a boolean with the value true, and delete loan is going to be super simple. First, we are trying to fetch based upon the mobile number. If there is no record, we are throwing resource not found exception. But if there is a loan record, we are trying to delete by ID, and to this delete by ID, we are passing the what is the primary key value, and this primary key value is loan ID, which we fetched from the database by using the find by mobile number method. This way, we implemented all the business logic, and all the packages are similar. There is a audit aware IMPL, which is going to insert the auditor name as loans_microservice. And there is a constant file with all the relevant constant fields. And we also have exception package where we have global exception handler, where we have tried to handle all the input validation failures, runtime exceptions with this exception handler. So most of the stuff is very similar to accounts microservice. And I hope it is very, very clear to you. Now, as a next step, I can go to the loans application. This is my main Spring Boot class. You can also see that this is a Spring Boot application annotation. Here, I'll try to start the application in a debug mode. Once the application is started in a debug mode, we can go to the Postman and we can try to validate the REST APIs of loans microservice. Do you know at what port my application is going to start? It is going to start at the port 8090. This is what we have followed for the loans microservice. Now I'm onto the Postman. Like I said before, you can always import the collection from the GitHub repo. If you import the collection by using this file import option, you will get a collection with the name microservice, and here open the loans folder, and inside the loans folder you will be able to see very first one, which is create loan. So this is a post operation, and this is the API path like localhost 8090 API/create, and we are going to pass a query param with the mobile number value. So like I said, please make sure you are using the same mobile number in accounts, loans, and cards. So there is no validation. Please make sure you are trying to follow that. This is just to make sure our life easy when we try to integrate all these microservices to get a combined response from all the microservices. So I'm clicking on this send button. You see I got a response saying that 201 loan created successfully. Now taking the same mobile number, I'll go to the fetch loan details, and this is a get operation with the API path fetch. And to this one, I'm going to pass the same mobile number, and I'm clicking on the send button, and you'll be able to see this is the mobile number, this is the loan type, total loan is 100K, amount paid is 0, outstanding amount is 100K. So now I can take this body inside the response, and I'll go to the update loan details. And here I'm going to paste the body that I have pasted from the previous operation. I'll try to change few details here. Instead of home loan, I'll say vehicle loan. And amount paid, I'll also make sure I'm mentioning some 10,000 here, and outstanding amount obviously will be 90K, which is 90,000. Now if I try to click on the send button, you can see it is working perfectly. If I try to go and fetch the loan details again, you can see this the amount paid, which is 10K, and outstanding amount is 90K, and loan type also is changed to vehicle loan. So this is working perfectly. Before I try to delete the loan details, let's test some negative scenarios. Like inside the update loans, if I try to give a negative amount for the total loans and amount paid and outstanding amount and loan number also, I'll try to give some more than 12-digit number. If I try to send it, you can see I'm getting all the validation errors. So this is working perfectly. Even for the fetch loan details, I'll try to give some 9-digit mobile number. I'll get a validation error. It is working fine. Now, instead of giving a valid 10-digit number, I'll try to give a invalid 10-digit number, which does not exist inside our database. So with this mobile number, you can see I'm getting a resource not found exception, which is loan not found with a given input data mobile number. So this is also working fine. Let me try to fetch again with a valid mobile number. I'm able to get it here. Now here we can invoke the delete operation, and I'm passing the valid mobile number. If I try to click send here, you can see the loan details are successfully deleted. If I try to fetch the loan details now, you will be getting a not found exception. So this confirms all our negative scenarios, exception handling, business logic, everything is working perfectly like we expect. I hope you are super clear and super happy with the progress that we are making. In the next lecture, I'm going to explain very similarly about cards microservice. If you got bored and if you're already aware about all these cards microservice, you can skip the next lecture. But if you want to quickly check, I'm fine with that as well. The reason I'm trying to demo all these microservice multiple times is so that all the business logic and the coding standards that we have followed will enter into your subconscious memory. The plan is if I try to explain all these three different microservices like accounts, loans, and cards, by the end of the course, each concept, each configuration, we are going to repeat 3 times. One time I'll be showing in the live, which you can see and observe the information. And if needed, you can practice the same with the help of 2 other microservices like cards and loans. But if you want to sit back and enjoy the course, you can also do that. And I'm going to do the same thing 3 times in 3 different microservices. That way, this is going to be super helpful, and you will never. There is a saying, with great power comes great responsibility. Like you can see here, we have the character Grogu inside the Mandalorian web series of Hotstar. This Grogu has lots of natural powers, but he don't unnecessarily show off his powers and use them only when required. Similarly, many other superheroes that we have like Superman, Spider-Man, or Iron Man, they all follow this rule, which is with great power comes great responsibility. They don't use their powers unnecessarily, or they don't use their powers on the innocent peoples. When you are building a microservice application inside any organization, you need to reverse this saying that with great responsibility comes great power. The reason why I'm saying this is if you take a lot of responsibilities and accept a lot of challenges that you face during the microservice implementation and handle all those challenges with the best possible standards inside the industry, then you're going to get great power from your microservice application in the form of all the advantage that we get from the microservice application. You might be scratching your head why this fellow right now is saying all this story. The reason I'm telling all this is right now we are ready to face a new challenge. I thought of giving some motivation to you. Don't get demotivated by seeing all the challenges that we are going to face while implementing microservice application. If you face all these challenges and implement a perfect microservice application, towards the end, you are going to have a perfect microservice application using which your organization can enjoy all the benefits. With this small motivation talk, let me introduce a new challenge. The new challenge that we are going to discuss inside this section is how to handle deployment, portability, and scalability of our microservice. First, if you try to take the deployment, you may have a question like, how do we deploy all the small microservice that we have with less efforts and cost? With the Moltech application, we have only a single application or a single jar or var or EAR file, which we can deploy into a web server or application server. Whereas with microservice architecture, we're going to have hundreds of microservices in any organization. So how do we deploy all those hundreds of microservices? Do we need 100 different servers and virtual machines to deploy them? Of course not. That is not going to be a viable solution. We'll explore what are the options that we have. Now, after deployment, if you think from portability perspective, how do we move our hundreds of microservices across environments with less effort, configurations, and cost? Like any web application, regardless of monolithic or microservice or any other architecture, it has to be deployed in various environments. Right from the developer mission, it will go into the GitHub repository or any other versioning system. From there, we need to deploy into the development environment. Once the dev build is stable, we need to move to the UH environment or SIT environment or QA environment. Once the testing is completed, we need to deploy the same into the production replica environment. Once the pre-production testing is completed, eventually the deployment has to be done inside the production. If you see, the code has to move across many environments. With the monolithic, there is only single application, single server. We can move the code by making enough configurations with very less efforts. But with hundreds of microservices, who's going to take care of all the portability issues? If your application need a specific JDK version or a specific web server or a specific folder structure or specific DB configurations, who are going to do all those manual work when we have hundreds of microservices? So these are another problem or another challenge that we may have. And after the portability, we also have another challenge in the form of scalability. Scaling a monolithic application is going to be super easy because you have only a single server. You can try to onboard one more server, which is replica of the existing monolithic server. With microservice, the story is different. We may have hundreds of microservices. How do we scale a specific microservice whenever we want based upon the traffic needs? So we need to scale the microservice on the fly based upon the demands. And at the same time, whenever we don't need, we need to scale down. So this all has to happen with the minimum effort and cost, of course, without any manual intervention. So these are the three challenges that we may face whenever we try to build microservice with a traditional monolithic mindset. So we need to change our mindset. We need to change how we package our web applications. In the traditional approach, you package your application as an var or EAR or a jar, and you will eventually deploy into a web server or app server. But that is not going to work. We need some new technique which we can adopt inside our microservice applications. So do you have any clue what is this new technique? Let me reveal the solution that we can use to overcome this challenge. The solution is containerization of our applications. To overcome all these challenges, first we should containerize all our microservices. Why should we containerize our applications? Because when we containerize our applications, we are converting a normal Maven project into a container. These containers are very small in nature, which offer a self-isolated environment for applications, including all the necessary dependencies. If your microservice require a Java version or a Tomcat or DB configurations or any folder structure, you can club all those dependencies inside a container, and the same container you can deploy across any environment or across any cloud environment without making any changes. I'll be showing all the benefits of this containerization in this section. So the very next question you may have is, how do we containerize our Maven applications? For the same, we have a solution which is Docker. You might have heard about this Docker already. So Docker is an open source platform that provides an ability to package and run an application in a loosely isolated environment called a container. You have a Maven application. With the help of this Docker, you can convert that into a Docker image, and eventually you can run that image as a container inside any virtual machine or inside any cloud environment. I know you may have many questions inside this section. I'm going to give a very good introduction about Docker. What is Docker? How we can containerize our applications? What are the challenges that it is going to solve? With all this section is going to be interesting. Before I try to close this lecture, let me give a quick introduction how this containerization came into picture. You see a ship here. So I have a question here. What do you observe from this ship? If you observe this ship, it is carrying lot of goods from one country to other country with the help of these containers. So why they are using these containers? Why can't they simply carry all the goods without these containers? Because with the help of these containers, they are able to optimize the space. They are able to provide a separate environment, a separate isolated space for each of the good. Like inside a container, there can be apples which need a refrigerator. Whereas inside other container, there are some electronic goods which does not require any cooling or refrigerator. Similarly, in a real world web applications, every web application may have its own requirements. One microservice may want to use Java 17 version, whereas other microservice, it may want to use Java 21 version. Similarly, there can be many different requirements for different microservice in terms of database, in terms of framework they use, in terms of language they use. If you try to manage all these microservices inside a single virtual machine or a single Jumbo server, it is going to be hell of work, and at the same time you're not optimally using all the resources of your server. So just like how the ship is using the resources optimally with the help of these containers, the same way we are going to convert our microservices and deploy them as a containers. That way inside a single virtual machine or a single Jumbo server, I can deploy 10 different microservices with 10 different requirements, because every container will have its own isolated environment. How it is going to have, how that is possible, we are going to discuss in the coming lectures. But for now, I just wanted to highlight, whenever you're thinking about Docker and containers, just think about this ship. What are the advantages that it is getting with these containers? Very similarly, just like how the shipping industry is taking the advantage of. In the previous lecture, I introduced a lot of new jargons like containerization, containers, and Dockers. Before we try to understand all these jargons and how to convert our microservices into Docker containers, first let me try to clarify a burning question that you may have, which is, what are these containers and how they are different from the traditional virtual machines? Before cloud computing days, every organization, they used to buy their own hardware, and using this hardware, they will install the operating system. So once a hardware and operating system is installed, we can call it as a server, and this server will be connected to a public network. Inside this server, the code will be deployed with the help of web server or app server, and there'll be a public IP address assigned to your server. So the platform team or operations team, they will map your public IP address to your domain name, and using the same domain name, my end user can access my web application from his local browser. So this is the basic and old story that you are aware. But with the cloud computing concept, we don't need to buy a server physically and maintain that inside our own data centers. We can buy a server virtually from the cloud providers, and the cloud providers behind the scenes, they will give you a virtual machine. Why the server is called as virtual machine? Because you can't physically see it. You can only feel it virtually, and you can access it through the web internet. That's why they're called as virtual machines. So let's try to understand how these virtual machines are created. Like you can see here at the bottom of this table, we have server. So this is a physical hardware. So think like a cloud provider like AWS, Azure, or GCP, they'll have a physical hardware or a physical server available in their data centers, and they can't assign a server to a single organization because the server capacity might be 64 GB RAM, and it also holds 4 terabyte of hard disk. So they can't give this entire Jumbo server to a single organization, because there will be very rare such instances where an organization will request for such a Jumbo server. So that's why on top of this server, they will use a technology, or they will use a concept called hypervisor. Using this hypervisor software from the same physical hardware, they can create multiple virtual machines. You can see here from the same physical hardware, there are 3 virtual machines created like VM1, VM2, and VM3. Inside these each virtual machines, we can install our own operating system. Like inside VM1, I can have a Windows operating system, and inside VM2, I can have Linux operating system, and inside VM3, I can have Mac operating system. So it's up to us what operating system we want to install. With the hypervisor, while we are creating a virtual machine, we can install required operating system based upon our own requirements. So here it is very clear the resources like RAM, hard disk of the physical server is virtually distributed between multiple virtual machines with the help of hypervisor concept. So now this VM1 can be given to a company 1, and VM2 can be given to the other company, and so on. So now coming to the microservices environment, think like there is no containerization concept. We have to live with these virtual machines. In such scenarios, what we have to do, suppose I have 3 microservices like account service, loan service, and card service. So for account service, I may need some JDK version, and similarly, I may need some web server or app server or Maven installed. So all the required binaries and libraries I have to manually install inside the VM1, and similarly, I have to do inside the VM2 and VM3 for the required binaries and libraries of loan service and card service. So after creating my virtual machine with the help of guest OS, and after that I will install the required binaries and libraries. Post that only, I can deploy my accounts microservice or loans microservice or cards microservice into my virtual machine. Once this deployment is completed, anyone can access my microservice using the public IP address. So behind the scenes, the cloud providers, they'll assign a public IP address for each of the virtual machine that they are going to create. The same public IP will be mapped to your DNS name or domain name, and using the same domain name or DNS name, we can access our microservice from outside the world. So this is the story with the virtual machines. And here you may have a question, what's the problem with this? I can deploy all my microservice into separate virtual machines. There are multiple problems here. First, here I'm trying to show you only 3 microservice. What if you have 100 microservice? Please don't answer like I'll create 100 virtual machines. That is going to be a super complex process, and it is going to attract a lot of cloud bill for your organization. So when you create a virtual machine, it's a big mission. It is as good as your laptop, which has 16 GB RAM and 1 terabyte hard disk. Inside such a big mission, if you only deploy a small microservice, do you think it is a viable solution? Of course not. And similarly, you may think like, why can't I deploy account service, loan service, and card service inside a single virtual machine? Even with that approach, you may face some challenges like your accounts microservice may need a Java 8 version, whereas your loans microservice may need a Java 17 version. And similarly, cards microservice may need some other program language like Python. So if you try to deploy all these microservices inside a single virtual machine, you see we will face lot many problems when we have different requirements for different microservices. On top of that, we have one more problem like if you try to restart your virtual machine, all your account service, loan service, and card service will be down, which is again a not an acceptable risk by any organization. And at the same time, in terms of scalability, suppose you want more number of account service instances deployed in some other virtual machine. Your accounts microservice is receiving a lot of traffic. All of a sudden, you decided to scale up your accounts microservice from 1 instance to 3 instance. With the virtual machine concept, by the time you create a virtual machine, by the time you install a guest operating system, by the time you complete all the binaries and libraries installation and scale your accounts microservice, it is going to take at least 15 minutes of time. With such a long 15 minutes of time, you can't really call it as a real scalability, because within that 15 minutes, your traffic may get reduced. By the time you scale up your accounts microservice, your traffic reduced to normal traffic. And again, you decided to scale down from 3 VMs to 1 virtual machine. Again, deleting the virtual machine also is not a simple and easy task. It will easily take again 5 to 10 minutes. Apart from these challenges, there are many other challenges if you try to deploy your microservices using a virtual machines concept. That's why whenever you are trying to deploy your microservices, please say a big no to the virtual machines. Instead, we should go for the containers. So let's try to understand how these containers are different from virtual machines. If you see at the bottom, the server, the physical hardware is going to be same for the virtual machine and the containers. On top of this physical hardware, a server will install a host operating system. So here it can be an Windows operating system or Linux operating system or Mac operating system. So once you have the server and host operating system, you need to install an implementation of container engine products like Docker. So once you install the Docker, with the help of the Docker, you can create multiple containers. And inside these containers, you can deploy account service, loan service, and card service. So if you see the beauty here, for the containers, there is no need of separate operating system. They will share the host operating system. So when the guest operating system is not there for containers, they are going to become lightweight, and creating a container and destroying a container or restarting a container is going to take only few seconds. So that's the very first great advantage that we have with containers compared to virtual machine. So they are lightweight and they're going to be super quick in terms of restart, creation, and destroying. Now, the other advantage that we have with containers is inside the same virtual machine or inside the same server, they can have a separate isolated environment. So think like all these 3 containers are deployed inside the same virtual machine or inside the same server. But the advantage with containers is inside the container 1, I can have Java 8 version, and inside the container 2, I can have Java 17 version, and inside the container 3, I can have different language, which is Python installed. So that's one more advantage. Every container will have its own isolated virtual network and virtual environment. The container 1 will not know about container 2 and its environment, and the same applies for vice versa scenario as well. Like I said before, these containers are a packed components where all the required dependencies packaged. Like if your accounts microservice need a JDK and Spring Boot related libraries, all of them will be clubbed and be available inside the container 1 itself. Due to that, whenever you're trying to create a new container inside another server or inside another environment, it is not going to be a super manual setup. You don't have to install the Java. You don't have to download the Spring Boot libraries. You can just take the packed component of the container to some other environment, and you can convert that package to a container with a single command. So that's one advantage. So this will solve the portability issue. Now the deployment also is going to be super easy because these are lightweight components, and restarting, creating a new container, destroying the existing containers is also going to take only few seconds. And every container will have its own network, own resources, own memory, own storage, which can't be accessed by the other container unless someone allowed it. So on a high level, I just wanted to say the main difference between virtual machine and containers is containers, they don't need the guest operating system, nor the hypervisor to assign the resources. Instead, they will use the container engine, which is Docker. I know you may have many other questions, but when we try to convert our microservices into containers, all these benefits and advantages I'll be showing you in action, and that will make more sense to you about these containers. I hope you're clear about what are the differences between virtual machine and containers. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let me try to explain you the formal definition of containers and Docker. The reason why I'm spending a lot of time on introducing these containers and Dockers to you is, as a microservice developer, it is a mandatory skill for you to aware about few important technologies like containers, Docker, Kubernetes. That's why inside this course, I'm going to put a lot of efforts explaining about all these concepts. As a Java developer, as a microservice developer, you will be asked a lot of questions inside your interviews and your projects, and you should be in a position to answer all such questions. That's why I'm trying to convey all this information. One of the questions that anyone can ask you inside an interview is, what is a container? A container is a loosely isolated environment inside a server or inside a virtual machine or inside your local system as well. Since you are getting an loosely isolated environment inside a machine, you can use that isolated environment to deploy your microservice by using software packages. So these software packages include all the code and all the dependencies to run your applications or microservices quickly and reliably on any computing environment. Your containers, in order to run, they just need the required code and dependencies along with the computing environment. And this environment can be your local system. It can be a virtual machine inside a data center, or it can be a virtual machine inside a cloud environment. So the computing environment can be anywhere. Your container is going to work very similarly like it works inside your local system. That's why regardless of how many environments you are trying to deploy your microservice, you are going to use the same container, and there won't be any manual efforts to set up your container, to install the dependencies, to install the required servers. So everything is going to be available inside the container itself. Like I said, all the required dependencies and libraries are available inside software packages, and these packages, we call them as container images. So from our microservice application, we are going to generate a Docker image or container image. From the container image, we can create any number of containers. So think like this image is like your Java class. Just like how your Java class is a skeleton or representation of your object, very similarly, this container image is a representation of your container. From this container image, you can create any number of containers, just like how you can create multiple Java objects from your Java class. In other words, your Docker container is an actual running representation of your Docker image. We'll see the demo in the coming lectures. Post that, the next definition that I want to share here is what is software containerization. So using this containerization concept only, we need to convert our microservice applications into your Docker containers. So what is the software containerization? It is an operating system virtualization methods. Like we discussed in the previous lecture, we can deploy multiple containers inside a single machine or a virtual machine. And all these containers, they are going to get a virtually isolated environment. And these containers, they will feel like they are running inside their own operating system. So with this containerization concept, we are virtualizing entire operating system. Whereas with hypervisor, if you see, we are virtualizing the missions. All these virtual missions like VM1, VM2, VM3, they will feel like they're all running in different physical hardwares, but they are not, because with the help of hypervisor, we are virtualizing the missions. Very similarly, with the help of containerization, we will virtualize the operating system. So all these container 1, container 2, container 3, they are running on a same operating system, which is host operating system, but they will feel like they are running in a separate operating systems. So since we are providing such kind of virtual isolated environment inside the containerization concept, the virtualization is at the operating system level, whereas inside the virtual missions, the virtualization is at the hardware level. I hope it is clear. Now we know what is a container, what is a software containerization. The next question is, what is a Docker? Docker is a open source platform or a product that enable developers to convert their web applications or to convert their application code into a Docker image. Using the same Docker image, and with the help of this Docker, we can automate the deployment, scaling, and the management of the applications with the concept of containerization. I hope you are able to tie the strings here between these three components. So software containerization is a concept. Docker is a platform which implements this containerization technology. So using the Docker, we are going to generate the Docker images and Docker containers from our application code. Now let's try to understand what exactly is going to happen inside the containerization concept. Like I said, containers, they are going to get isolated environment. How they are going to get? Because containers are based on the concept of operating system virtualization, where multiple containers run on the same physical or a virtual machine that shares the same operating system kernel. And this is different from the traditional virtualization that we follow whenever we are trying to create multiple virtual machines, and these virtual machines run on their own separate operating system instance. Whereas with Dockers, they're going to share the same operating system kernel. So inside this containerization, Linux features like namespace and CG groups play a crucial role in providing the isolation and resource management. So let's try to understand what are these namespace and CG groups. Namespace is a concept inside Linux which will allow for the creation of isolated environments within the same operating system. So each container will get its own set of namespace, and this namespace is going to have process resource, network resource, and any storage resources, communication resources, and similarly user namespaces. So these namespaces ensures that process within a container are only aware of and can interact with the resources within their own specific namespace. So this provides a level of isolation from the other containers. I hope you understand. It's very simple. Using namespace for a container, we are giving its own network, process, storage, everything, so that all the components inside the container are inside the namespace. They can interact with each other, but not other components inside other container or inside other namespaces. Now coming to the CG group. What are CG groups? These CG groups also called as control groups. The reason why we call them as control groups is namespaces will provide the isolation of the resources, but someone has to control the uses of the resources by a container. So with the help of these control groups, we can administrate and control the uses of the resources like CPU, memory, disk, network bandwidth. That way, for the containers, we can enforce resource restriction at runtime and try to avoid the scenarios like one container from monopolizing the system resources and ensuring fair allocation between multiple containers. Since we can deploy multiple containers inside a same virtual machine or inside a same computing system, we need to make sure every container is getting its own fair allocation. It should not be like one container is getting very less allocation, whereas other container is getting a lot of memory allocation or CPU allocation. That is not fair, and it may result into issues dynamically at runtime. That's why with these concepts of like namespaces and control groups, a separate isolated environment will be provided to the containers. Here, you may have a question like, these are the Linux features. If these are the Linux features, then how I'm going to containerize my applications from my local system, like inside my Mac OS or inside my Windows operating system. Even it is also possible your production server can be a Windows server. So in such scenarios, you may have a question like, these are the Linux concept. Then how the Docker containerization or containerization concept is going to work inside my Windows operating system or Mac operating system. So let's try to understand the same. Whenever you try to install an Docker on a Linux operating system, it is inside this lecture, let me try to explain you what are the important components available inside the Docker and what is the internal architecture of Docker. The very first important component that we have is Docker client. Like I said before, whenever we try to install Docker inside any system, we get Docker client and Docker server. So using this Docker client only, we need to give instructions to the Docker server on how to containerize our applications. So inside this Docker client, there are two different components that we can use to issue the commands to the Docker server. The most commonly used approach is Docker CLI. Using this command line interface, we can issue commands to the Docker server directly from your terminal or from your command line. This is very similar to GitHub CLI or AWS CLI or any other CLIs provided by the other products. Apart from CLI, you can also issue commands to the Docker server using APIs. Using this Docker remote API, we can issue commands like how to run a Docker container from a Docker image. So all such commands we can give with this remote API approach as well. But inside this course, we are going to use the Docker CLI approach because that is the most commonly used approach. Apart from this Docker client, the next important component that we have is Docker server. In other words, we can also call this Docker server as Docker host. So when I say Docker server, don't think like this is going to be installed in some other remote mission. So both this Docker client and Docker server or Docker host, both of these are going to be installed inside your system. So inside this Docker server, there will be a Docker daemon process that is going to run continuously, which is going to accept the commands from the client. The client like CLI, we can issue commands to this server, like please generate a Docker image for my application. So for my application, these are the dependencies. This is the Java version that I'm using. These are the configurations that I need. So once we provide all those details or instructions to the Docker server, it is going to convert your Spring Boot application or Maven application or your microservice into a packaged software, which commonly called as Docker image. So image is a representation of your packaged application. So it has all the required dependencies and configurations packaged into a Docker image. Very similarly, we can also give commands to generate a container from a Docker image. Like you can see here, there'll be images, and very similarly, we also have containers. So we can't generate containers without a Docker image. First, we need a Docker image. When we give an instruction to the Docker server to generate a container from a Docker image, it is going to leverage the Docker image and it is going to create a running instance of your Docker image which is your web application or your microservice in a running state. So once a container is in running state, you can obviously try to access all your REST APIs or microservice business logic through the endpoint URL by using the correct port number, correct API path. I hope this is clear. So inside your Docker server only, all your images and containers are going to be stored. Now, this setup is going to work perfectly if you're working in your own mission. Once we generate a Docker image for our microservice, once we test that with the help of Docker container, and once we feel that everything is working, we need to push the Docker images to a repository from where we can continue to the steps like deployment and running the containers inside the dev environment, QA environment, or production environment. Just like how we store our Java code inside the GitHub repo, very similarly, we need to store these Docker images available inside our local system into a remote repository. That's where we have the third component available. This third component, we call it as Docker registry. Docker company itself, they provide a Docker registry with the name Docker Hub. Inside this Docker Hub, you can store all your Docker images and you can make them available for public use, or you can also protect them so that only authenticated users or applications will try to download your Docker images. Just like how Docker providing Docker Hub, very similarly, there are private registries provided by famous companies like GitHub, AWS, GCP, Azure. So most of the cloud providers and most of the version repository products like GitHub, so they have their own private registry where you can push the Docker images from your local system to these remote repositories. For example, if you are using AWS to a great extent inside your organization, then it makes sense to push your Docker images into a private registry provided by the AWS. From this private registry, all your deployment of the microservices will happen. Inside this course, I'm going to use the Docker Hub to store all my Docker images. So I'll show you how to generate a Docker image. And once the Docker image is generated inside our local, I'll also show you how to create a running container from your Docker image. Once everything is completed, we can push these Docker images into a remote Docker Hub repositories. So these are the three important components available inside the Docker architecture. Now let me give a simple flow that will happen whenever I try to issue an instructions to the Docker server. So in the very first step, I'm going to give the instructions to the Docker server with the help of my Docker client. So the instruction may be like to run a container from a Docker image. So as soon as I give this instruction, my Docker server will validate if the Docker image is available inside my local system. If it is not there, it is going to fetch the required Docker image from the remote repository like Docker Hub. Once the Docker image is pulled into my local system using the same Docker image, a container will be created by the Docker server. So once a container is available, it means my application is ready and I can try to use the application. These days, many of the products, they are providing everything as part of a Docker image. For example, if you want to use a MySQL inside your local system, the traditional or older approach is you'll go to the MySQL website, you'll download the MySQL installation, you will install inside your system. So that is very cumbersome process and a lengthy process. Instead, with the help of Docker, you can pull the image of MySQL. Once the image of MySQL is pulled from the Docker Hub, you can try to run a container from the image. That means you are going to have MySQL server running inside your system. I hope you are clear with this Docker architecture. In the next lecture, I'll show you how to install Docker inside a local system. I hope it is clear. Thank you, and I'll catch you in the next lecture. Bye. Now is the time to install Docker inside your local system. I already installed Docker inside my local system long back. That's why I'm not going to install again inside my system, but I'll show you the steps that you need to follow to install the Docker inside your system. These steps are going to be pretty straightforward and pretty easy. So please do follow these steps and make sure you are installing the Docker inside your system. Without installing Docker, you cannot practice all the microservice concepts that we are going to discuss from now onwards. If you have intentions to practice along with me, please make sure you are installing the Docker inside your system. Like you can see here, first we need to visit docker.com. This is the website. Inside this website, as soon as you land on this homepage, you have an option to download the Docker desktop. Since mine is an Mac operating system, it is automatically detecting that and it is asking me to download the Mac related Docker desktop. Based upon your operating system, you can select any of the operating systems available like Apple, Windows, and Linux. So once you select, you can click on this download Docker desktop option, and post that, it is going to be simple. You just have to double click on it and click next, 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 and finally the Docker will be installed inside your system. If you have any challenges in installing the Docker inside your system, you can me, or you can also take help from the Docker community. You can check there is a lot of help available from the Docker community inside the websites like Stack Overflow, Docker community. So there is enough help for you to resolve any Docker issues. So don't get demotivated. The installation is going to be super easy. So once the installation is completed, you can click on the sign in button, which will take you to the website called hub.docker.com. So since I already created an account, it is already logged in me. So EasyBytes is my account or username. If you don't have an account, please make sure you're also creating an account, and your account should have an username and it will have password. There is no need of providing any credit card details. So once the account is created, you can log in into the Docker Hub. So this is the website, which is hub.docker.com. So please remember your username. In my case, the username of my Docker website is EasyBytes. We need to use the same inside the coming lectures. So like I said, Docker Hub is a place where you can find the Docker images, or you can also store your own Docker images with the public access and private access. If you want to store the Docker images with the private access, then definitely you need to upgrade your plan. So if I click on this upgrade, you can see it will show you all the plans available. As of now, I'm using this personal plan, which costs me $0. So with this, I can store Docker images in unlimited public repositories. For this course, we are good with this personal plan. But in real projects, since we want to store our Docker images in a secured manner, usually inside your organization, they will provide a Docker login from any of these plans, mostly business plan. But don't worry, for now, you can happily use this personal plan. So let me go back. With this personal plan, I can only store my Docker images inside public repository. That's fine for me, because my intention also to store all my Docker images inside a public repository so that you can also access them. We can create a new repository, but we'll see that later. But for now, I just wanted to show you, like you can see, many products, they store their official images inside this Docker Hub only. You can see Python has their own Docker image, Postgres, Ubuntu, MySQL. See, they have 1 billion downloads from this Docker Hub, which shows how many developers are using this Docker. So that's why it is very important for us to learn this Docker. For now, let me try to search a Docker image with the name MySQL. So if you try to MySQL Docker image, you can see this is the MySQL Docker image. There is also a tag Docker official image, 1 billion times download happened. So in order to get this Docker image inside your local system, you just need to run this command, which is docker pull MySQL. We'll deep dive into all those commands. Don't worry. But for now, I just wanted to show you that inside this Docker Hub, we can store our own Docker images. And at the same time, we can also find and fetch all the Docker images of other products that we want to use. If you want to use a database, or if you want to use a server, or if you want to use a language. So all of them are available as a Docker images inside this Docker Hub. Once you install the Docker and created this Docker account, you need to click on this Docker icon available inside your local system. As of now, you can see I have already logged in, so I can click on this dashboard. So this is my Docker dashboard, where you can see all my local Docker images, Docker containers, Docker volumes. We'll be using this Docker desktop a lot, but please make sure if you're not logged in already. Are you ready to generate Docker image from our microservice? I know you are super excited and you are super ready. By quick introduction about this, the most basic approach. Second approach that we have is build packs. With the help of build packs, we don't have to write any Docker file. So build packs is a project initiated and developed by Heroku and Pivotal based upon the best practices that they have learned over the years. So this build pack simplifies the containerization of our web applications. How it is going to simplify is we don't have to write any low-level Docker file like in the first approach. And using this approach only, we are going to generate a Docker image of Loans microservice. Now, the last approach that we have is Google Zip. Google Zip is a product developed by the Google itself. Later on, they open source this Java tool. Using this Java tool and with a Maven plugin command, we can generate a Docker image of any Java application very easily without writing any low-level Docker file like in the first approach. So all these approaches, they have their advantages and disadvantages. I'm going to discuss in detail while we are discussing each of this approach. So using this Google Zip approach only, we're going to generate a Docker image of Cards microservice. Here, you may ask me a question like, since there are 3 different approaches, is that the reason why I'm building 3 different microservices like accounts, loans, and cards? Of course not. That's simply a coincidence. I have developed 3 different microservices inside a bank application. And luckily, there are 3 different commonly used approaches to generate Docker image from a Spring Boot web application. That's why, like you can see, I have given a mapping of each approach to a microservice. But by the end of this section, like I said, we are going to select one of this approach and we are going to follow the same throughout this course. I hope you are excited about these 3 different approaches. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let's try to understand how to create a Docker file and how to provide instructions to the Docker server to generate a Docker image for accounts microservice. For the same, I came to my workspace location. As of now, you can see I have a folder with the name section 2. And at this section 2, there are 3 different microservices with the name accounts, cards, and loans. Now, since we are into a new section, which is section 4, I'm going to copy the same section 2 code and paste the same inside the same folder. Post that, I'm going to rename this section 2 to section 4. There is no code related to section 3 because section 3 is a theory section where we have discussed about how to right size our microservices and how to identify service boundaries for microservices. This will give me a flexibility to upload all this code based upon section and in an incremental manner. So whatever code that you are going to find inside this section 4 is an continuation of the previous section. We understand what changes I have my IntelliJ IDE. Click on this open. This will open. Try to look for the hidden workspace. It's going to recognize all your projects as a Maven project, and you should be able to see all those Maven Docker image with the approach. Since we want to generate Docker images for our accounts microservice or any other microservice, we need to make sure we are mentioning this packaging as jar. This tells to my Maven that, so that's why I'm going with this happen using the same microservice. As of now, you can see there is no jar file inside the my target folder of accounts microservice. First, I'll try to delete all the existing only compiled classes and set the target folder. Now I'll start by choosing this option new terminal at folder. So you can see right now my terminal opened at accounts folder. If I try to run the pwt command, which will print the present working directory. So this is the present working directory, and the section 4 I have accounts microservice. In other words, you need to open your terminal or command line, and at the folder location pom.xml file is available. Open the terminal. Your Maven is installed inside your system and you have set up the Maven home path. Since this is very basic, I'm not covering about how to install Maven in the Java home path. In order to confirm whether the Maven is installed inside your system or not, you can run a command which is maven-version. This will give which version of Maven is installed inside your system. So like you can see, Apache Maven 3.8.6 is installed inside my system. So regardless of what version you are using, please make sure this output is printed. Now, as a next step, I'm going to run a command which is maven clean install. Using this command, I'm telling to my Maven to compile my Spring Boot application with the name account. So inside this accounts folder, there is a file called pom.xml. If you can go to the pom.xml, towards the end, if you go, there is a build related configurations that are available. There is a Spring Boot Maven plugin is already configured inside our pom.xml. So please make sure these configurations are available. Now, if I try to run this Maven clean install behind the scenes, my Maven is going to compile my accounts microservice, and it will also do a small basic unit testing. And if the unit testing is successful, it is going to generate a jar. If you see, it has done some unit testing and there are no errors. That's why my build is successful. Now, if I try to go and check my accounts target folder, under this target folder, you'll be able to see a jar generated with the name accounts-0.0.1-snapshot. So this is a jar of around 54 MB. We call this jar as a fat jar inside Spring Boot because inside this fat jar, it is going to have all kind of dependencies except Java runtime. So it will have all the Spring Boot libraries. It will have embedded Tomcat server. So all the dependencies related to accounts microservice is going to be available inside this jar except Java libraries. You may have a question here like how this name is coming. If you go to your pom.xml, here the artifact ID is accounts. The version comes by default 0.0.1-snapshot. If needed, you can change this value. So based upon the combination of this artifact ID and version, the jar name will be derived. Please make sure you're also following the same artifact ID like me so that any issues that you may face, you can always try to compare my code with your code. And if you're still not able to identify the root cause of your issue, you can always share your code with me. And if you follow the same naming conventions like me, then my job is going to be super easy and I can respond to you as soon as possible. So now we have the jar generated for this Spring Boot application. My entire Spring Boot application or my entire microservice application with the name accounts is right now available in the format of this jar present inside the target folder. Now with the help of this jar, I can try to start my Spring Boot application using a Maven command. For the same, first let me clear the console and I'll run a command which is maven spring-boot:run. When When I try to issue this command, which is spring-boot run, behind the scenes inside my pom.xml, since I have a plugin with the name Spring Boot Maven plugin, this plugin is looking for a jar inside my target folder, and using the same jar, it is going to start my web application. Let's try to validate the same. So as soon as I execute this command, you can see my Spring Boot application is being started, and it started at the port 8080. I can also test my accounts microservice. For the same, here inside my Postman, I'm going to create a new account by passing a request. You can see I'm getting a successful response. I can also try to run one more API, which is Fetch API. And you can also see I'm getting a successful response. So this confirms our accounts microservice is successfully started with the help of a Maven command. Now let me stop my accounts microservice by pressing Ctrl C. You can also try to press Ctrl C together, and that will stop your running instance inside your terminal. Now I'm clearing the console. This time I'm going to show you a Java command instead of a Maven command. Since inside Docker image, we don't want to unnecessarily install a Maven. So that's why I'm going to show you how to run your Spring Boot application with the help of a Java command. The command is java space -jar, and my jar is present inside the target folder. That's why I need to give this target / and the jar name is accounts 0.0.1 snapchat.jar. So this is the command that I'm trying to execute. Whenever I try to run this Java command, you can see the same effect, like my web application will start at the port 8080. The reason why I'm trying to show a demo of all these commands is this knowledge is going to help you to write a Docker file. With this, I'm assuming you are clear about what we have done inside this lecture. In the next lecture, let's try to write a Docker file, and using the same Docker file, we can try to generate a Docker image of accounts microservice. Thank you, and I'll catch you in the next lecture. Bye. Inside this lecture, let's try to write a Docker file for our accounts microservice. Before we try to do that, let me stop this running instance of my accounts microservice by pressing Ctrl C. So this will shut down my accounts microservice application. Let me clean the console. After stopping your accounts microservice, please make sure you also started the Docker. You can see my Docker is already running. That's why I'm able to see this icon here. So inside Mac, you'll be seeing in the top, whereas in Windows, you'll be able to see in the down right corner. If you click on this Docker icon and click on this dashboard, you should be able to see all these containers and images right now inside your Docker local. If there are no images, there are no containers, everything will be empty. This confirms that our Docker server is running inside our local. Now, as a next step, like I said, first we need to create a Docker file. So right click on your accounts microservice folder and select the new file option. The file name has to be Docker file. Please make sure you are following the exact file name, because Docker will look for the exact file with the name Docker file, and this should not have any extension. That's why don't give .txt or .xml or .yml. There's no need of any extension. You can simply create a Docker file without any extension with the name Docker file. So I'm just pressing enter. Now inside this Docker file, we need to write instructions that can be used to generate a Docker image for my accounts microservice. In order to run my accounts microservice, anytime whenever I want to run my accounts microservice, the very first basic requirement that I have is to install JRE or Java inside any system. That's why I should communicate the same to my Docker, saying that my accounts Docker image has a dependency on Java. For the same, we are going to use a keyword from inside the Docker. Using this from command, we are telling to Docker that my Docker image has a dependency on some other Docker image. So please import this base image into my Docker image whenever you are trying to generate a Docker image of my accounts microservice. So that's what we are trying to tell with this from command. So to this from command, we need to provide the base image. Inside this scenario, the base image is Java. For the same, I'm going to mention openjdk : and post that. I'm also going to tell what is the tag of the Docker image. So this is the image name, like which is OpenJDK, and this is the tag name, which is 17-JDK-slim. Make sure there is a colon between Docker image name and the tag. Tag is very similar to version. Since I want to use Java 17 version, I'm providing this 17-JDK-slim. You can also search for this Docker image inside the Docker Hub. So this is my Docker Hub. If I try to search for OpenJDK, you can see there is an Docker official image with the name OpenJDK. Let's try to click on that. So whenever I want to use this Docker image as a base image for my own microservice, then we need to make sure we are providing the same Docker image name, which is OpenJDK. And if you click on these tags, there are many versions of OpenJDK available with different tag names. So if you use this 22-slim-bullseye, you're going to use Java 22 version. So since we decided to use 17 version, I'm going with the tag, which is 17-JDK-slim. So let me also provide some comments here. So I just provided a comment saying that start with a base image containing Java runtime. So this is the base image for our accounts microservice. Post that, I'm going to give a line space, and this time I'm going to invoke a keyword which is maintainer. Using maintainer, we can provide the details of who is maintaining this Docker image. So for now, I'm just going to mention easybytes.com. So please make sure there is a space between maintainer and this easybytes.com. So this tell to anyone who is trying to accounts and copy the same jar into my Docker image. When we generate a Docker image, it is going to have all the dependencies in a packaged form. So one dependency that we have is OpenJDK, and the other dependencies that we have is accounts jar. Inside this account jar only, we have all the business code, all the Spring Boot related libraries. So we're trying to copy this from our local machine to the Docker image that is going to be generated. And at last, we need to provide a command which is entry point. So please make sure you're also following these capital letters. So with this entry point, what we're telling is whenever someone is trying to generate a container from my Docker image, please execute so and so command. So to this entry point, first I need to provide the square brackets. And inside this square bracket, I am going to provide multiple commands, which is Java, comma, again double quotes, -jar, post that, comma, and at last, what is the jar name that I have, which is accounts -0.0.1 snapchat jar. So this is I'm going to copy and mention here. If you see, this is the same command that we have used to start our Spring Boot application with the Java command. So this is a command that we have used like Java -jar. And previously account jar is present inside the target folder. That's why we have given target folder. But inside my Docker image, it is present inside the root folder location only. That's why I don't need to provide target. And the reason why I have to provide all these commands separately in the double quotes, comma separate is since there is a space after each command, we need to follow this syntax whenever we are trying to give command instructions with the help of this entry point. So behind the scenes, whenever I try to generate a Docker container from my Docker image, my Docker server is going to execute this command, which is Java -jar, and it is going to use this jar. So this is the Docker file that we have written. With this Docker file, now we should be able to generate a Docker image successfully. Before I try to do that, let me try to mention comments for your reference here. So on top of maintainer, I'm going to mention comment saying that information around who maintains the image. Similarly, on top of this copy command, I'm going to mention add the applications jar to the image. Our application jar, we are copying to the image. And at last, on top of this entry point, I'm going to mention which is execute the application. So now we have written successfully a Docker file. In the next lecture, using this Docker file, let's try to generate a Docker image. I hope this is clear. Thank you, and I'll catch you in the next lecture. Bye. Now we have this Docker file ready inside our accounts microservice. As a next step, we need to provide this Docker file to our Docker server. And with that, my Docker server is going to generate a Docker image of accounts microservice by following all these instructions. So let's try to understand how to do the same. Inside your terminal, first make sure you are running the Docker version command. This will make sure the Docker is installed and it is also started properly inside your local system. So both this is the client version and this is the server version that I have running inside my system. As a next step, we need to make sure you are running a Docker build command. The Docker build command is docker build space dot. Since my Docker file is present inside the same folder location of accounts from where I'm running this command, I don't need to provide any file name or any folder path. But if your Docker file is present inside some other folder, then you need to provide that exact path. Since inside my scenario, the Docker file is present inside the same folder, I need to give this dot symbol. Post that, I'm going to give a space followed by -t. The T indicates tag. After this tag, we need to give what is the Docker image name that we want to consider for our accounts microservice. So whenever you're trying to give a Docker image name, you need to follow a standard format. The format is first we need to make sure we are providing the Docker account username. So the Docker account username is easybytes. So please make sure you're also providing your own Docker account username. Post that what is the name that you want to give for your accounts microservice. So the name that I want to give here is accounts followed by colon. And what is the version or the tag name of your Docker image? So right now I want to give as S4. S4 indicates section 4. Since we are into a section 4, I'm going to create a Docker image with the tag name and version name as S4. And this easybytes is my Docker account username, which I have created inside my Docker Hub. If you see here, this is my Docker username that you can see inside hub.docker.com. So you need to make sure you are giving your own username because we have the intentions to store all our Docker images inside this Docker Hub. That's why we need to give our username as well, which will be helpful for us in future when we are trying to push our Docker images. If you don't give your Docker username, then it's going to create some problems whenever you're trying to store your Docker images inside the remote repository. So that's why please make sure you are providing this prefix, which is your Docker account username, followed by / followed by what is your microservice name, which is accounts, followed by colon and S4. S4 is a tag name or the version number that I'm considering here. So with this Docker build command, we are telling to Docker server, there is a Docker file inside this folder. Please use that instructions and generate a Docker image with the name easybytes/accounts:/S4. So this is my CLI. So since I'm using command line interface, this is my Docker client or Docker CLI. From the CLI, I'm giving instructions to my Docker server running inside my local system. So let me execute this command. With that, you can see behind the scenes, my Docker server is trying to generate a Docker image. The very first step that it has done is it downloaded the base image, which is OpenJDK 17-JDK-Slim from the remote repository, which is docker.io library. So once it downloaded that base image, post that only it is going to look for the next instructions. So let this download complete. When you're running this Docker build command, please make sure your Docker server is running. Otherwise, your Docker build command is not going to work. Not only Docker build, any other command that you're going to run will only work if your Docker server is running inside your local system. So now you can see my Docker image is generated with the name docker.io easybytes/accounts/S4. You can also see the steps that it has followed. In the very first step, it downloaded the base image, which is OpenJDK. And in the second step, it copied the accounts jar from my local system inside the target folder into my Docker image. So now if I try to execute a command, which is Docker images, this will list all the images right now inside my local system. Here you can search for a Docker image with the name accounts. So there are many other Docker images inside my system. You may not have such images inside your system. Don't worry. The main image that you need to look is accounts. So if you see, this is the Docker image that I have generated with the name accounts, and the tag is S4. This is the image ID, and it is created a minute ago, and the size it has is 456 MB. If I try to inspect this image by running a command docker inspect image, and what is the image ID? The image ID, this is the image ID. You don't have to mention the entire image ID. Instead, you can simply mention the initial few 3 or 4 characters. So I'm just mentioning the same and trying to run this. So if you try to see with the inspect command, you'll get all the details about your Docker image. So there'll be some interesting information inside this output. First is the author is easybytes.com, which is coming from the maintainer. And post that you can see the Java home is set to the OpenJDK 17 because we have mentioned the base image as OpenJDK 17. So behind the scenes, since your accounts microservice need Java home to be set, and all that is taken care by the Docker server during the Docker image generation. And at last, you can see the entry point to generate a container from your Docker image is java-jar, and this is the accounts related jar. So we provided this information also inside our Docker file. And the operating system is Linux. Like I said, all the Docker concepts are going to work based upon the Linux concepts like namespaces and control groups. So that's why behind the scenes, it is going to follow the Linux operating system only. So this is important information that you can see. You can also explore more details about your image. Now inside this lecture, let me show you how to run a Docker container from your Docker image. As of now, like you can see, we have this accounts microservice Docker image inside our local system. We build this Docker image with the help of Docker build command. Very similarly, using Docker run command, we can run a container from our. Inside this lecture, I'll show you a problem that we may face with the current setup that we have, and post that I'll also show you a solution for the problem. As of now, you can see we have 3 different images like cards, loans, and accounts. These are the Docker images of 3 microservices that we have built so far. To run our microservices, we need to convert these Docker images into containers with the help of Docker run command. So if I want to start my 3 microservice, I need to issue Docker run command 3 different times along with the image name and the port mapping. What if I want to start multiple instances of my microservices? In such scenarios, giving this Docker run command manually for each microservice and for each instance of it is super cumbersome process, and it is time consuming process. If I have 100 microservices, I need to issue this Docker run command 100 different times, which is not a quite viable option for any human. To overcome this challenge, we have. Welcome back to the new section. This section is a small theory section where we are going to discuss about the definition of cloud native applications, what are the characters of cloud native applications, and 12-factor methodology and 15-factor methodology. These are the standards that any microservice developer has to know, because by following these standards only, we are going to build many concepts inside the microservice in the upcoming sections. So we are into a new section, and the slides color is also changed to a new color. I will be using various colors for my PowerPoint slides background.